what we're going to do is I'm going to go on to the live stream right now, and let's get into it. There's going to be all sorts of things I'm going to talk about, and I'd love to chat with you along the way too, so let me know how things are going. As you can see, this is the Vega 30 4-stroke RC engine on your screen right now. This has been one of the most enjoyable projects that I have ever done. And so we're not going to be talking about this. We're going to talk about something a lot more simple, because I've already actually produced this course. This course is available on Patreon and for paid members, and I'm trying to release a more polished version on YouTube as well. I think I got to lesson 6 out of 10 and then had to pull the plug on it because Autodesk came out with so many different updates, and it's kind of, I had to revamp how we're going about these tutorials. So I had to pull the plug on that temporarily. I'll start fresh from that in the meantime. However, for those that are familiar with Fusion and you are wanting to up your game a little bit, we can go right on over to the Patreon page, which I'll bring up in just a moment. Let me pull this up here. And there we go, Patreon. So as you can see right on the front page, we've got these versions. These are behind the scenes. This shows you all of the nitty gritty, a lot of mistakes as well that I make and have to overcome. We've got that 4-stroke RC engine, but we're not going to talk about that today. We are going right back to something new. And if you're interested in how to do motion studies, again, that's all talked about in the course. So I'm just going to go cancel there. Let's save this project and let's start from the get-go here. So I'm just going to exit out of that. I'm going to show you, this is kind of the fun thing about this, is I'm going to show you my entire workflow. We go right on over to the data panel. I'm going to go to home, and let's scroll on up to the top, and I'm just going to go to my pinned projects. I don't have any pinned projects right now as in starting scratch, so I'm going to create one. And what we're going to do, if you don't have the plan book already, I encourage you to go to the details of this, or the description of this video, and head on down to the plan book. There you can download it for free. And you'll have to go to the official website of where this plan book is from. There you can download it for free. But you will head on over to the Clanford Clan 0.24cc. So I think that is page 41. What I have done is I've printed all 4 pages of that plan, and that's what we're going to tackle together. So if you have a moment, go on over to that website, get the plan book. Make sure to click on the link in the description below. If you're not already a free Patreon member, that's where you can head on over and get that. It takes you to the official website where you can download the plan book. But please open up to the Clanford Clan. In the meantime, I've created a new project, and I'm just going to call this the Clanford Clan 0.24 cc. That's going to be my project. So the way that we look at things here, and of course it's gone now, so I have to go to all projects, and then we're going to go to the Clanford Clan 0.24 cc. And what I could even do is go back to the home, and I'm going to just pin this. So right click, or just pin right there. There we go. Now if I go up to the all projects, I can go pinned, and we've got the Clanford Clan 0.24. So here, the way that I like to think of things is we can go about this in many different ways, and this kind of frustrates a lot of new Fusion users. You know, like what kind of file do we pick? And again, we could just click on New Design here, and it brings up, do we want to create a part, an assembly design, or hybrid? So I've talked about this in a previous tutorial, and part design, you're just looking at one single component. However, within that component, you can create various bodies, and that alone is frustrating to us, but hopefully we'll get through that. There's an instance in here where we're going to talk about bodies within components, I think, within the Clanford Clan. Assembly design is create or insert parts and other assemblies as external components. So what this does is it creates one file, and it actually creates a bunch of external parts and automatically brings them into your assembly design. So we could do that, but that's very frustrating for some too, because it limits you. It gives you a lot more power and ability in design, but it also limits you greatly. Now, I'm just going to take a look at the chat here. Yeah, look at this. We're already at 9:43. This is great. And I see that someone's already worked on the Clanford clan. Great. Yes, keep them coming, everyone. I'll take a look at the chat as much as I can, as often as I can. But yeah, I'm trying to do many things here, and again, my brain's probably going to shut down at some point. So, anyways, what we're going to do is we're going to do the hybrid design, because this kind of encapsulates both of the best worlds, or the best world, the best of both of these design files. So we're going to start off with the hybrid design and just go create new. And again, we didn't actually have to do that, to tell you the truth. We could have just gone over here to the document settings and then hit the convert a design type and selected that right off the bat. So we could have done that. That's fine. Right after I selected the design file type, I like to save it. And for this, I'm just going to call it the Clanford. There we go, 0.24 cc. It's limited. Fusion is limited with what you can use in the title block, or in the title, I should say, where we might not be able to put quotation marks and things like that. But I could define this a little bit more. I could call it a design file or something like that, the CAD file. I'm just going to call it that, because hopefully we're going to get to, if we don't take forever with this, hopefully we're going to get to the rendering and doing all that. We won't do drawings on today's live stream. That will take too long, but rendering is pretty quick. So anyways, we've got this, and you can see there's no picture, there's no image in there because, well, we haven't created anything yet. So here's the thing. You need to get the design or the drawing package in front of you. There's so much going on there that we need to talk about. And obviously, the more that we do this, the more that you do this, the easier it will become. And what I like to do is, if you download that entire plan book, and again, I'm grateful that it's out there for free, but if you do and you're looking to expand your skills, I would take it just one engine at a time and have fun with it. Try and design as best as you can. But as I look at the drawing package, I can see there's 3 sheets and a cover sheet, right? Cover page. So we've got sheet 1, 2, and 3. Those have different names. We've got the crankcase tank for sheet 1, the cylinder shaft sheet 2, and the general arrangement on sheet 3. So when I look at sheet 1, that's what I'm going to start with. And here's a little secret for everyone out there. What you're going to do as you model and as you create components, basically, if you think about it like this, is create each component like you would in your real life assembly. So if you're putting this together on assembly line, what would be the first piece or component in your hand? Well, that's what we're going to start off with. And in my mind, that would probably be the crankcase. So I'm just going to go right ahead and do that. Now, before I create the crankcase, one thing that's very interesting is I would like to think about this a little bit more and think, okay, is this going to actually be an assembly? No, it's not necessarily going to be assembly. If it had like O-rings in it, and if it had subcomponents in it or something like that, we might include the back plate, but I don't think that's necessary as part of the assembly. But you just have to think of it that way. If you look at the tank top and the fuel tank, that actually has a brass tube in it. It has a top, it has a lock nut, and it has a fuel tank. So it's actually 4 components. And believe it or not, I think that the needle valve, yes, the needle valve is part of it too. So it actually has 5 components as part of that assembly. So we're going to create that as a subassembly within our hybrid design. But let's get started. And actually, just before we get started with the crankcase, I just want to say out there that everyone who comments, you will automatically be put into a draw where I would love to select someone at the end of it, and you will get a free gold membership of Patreon. So I'm just going to go back to Patreon for a second. And when I say gold membership, that is for an entire year, an annual membership. So let's just go over to Patreon real quick. Here we go. Let's go up to the top, and I'm going to go to memberships. Okay, so gold membership for me, $25 US per month. So this adds up. That adds up to a lot of money at the end of the year. So you can also start a 7-day free trial if you want, which is great. This gives you all sorts of benefits. You can view all of our courses. Titanium and gold memberships are the best. Aluminum is for those who want to just help us. There are limited tutorials and resources available. Titanium and gold, you get them all. We have currently several gold members, which I am very grateful for. Many have expressed appreciation for how much they've learned. It's helped them with jobs, getting jobs out there, believe it or not. And so once they've gone out of their way to support our channel with gold membership, which again, we're extremely happy for, and we will be giving that away. So if you want to comment away, and I'm going to randomly pick someone and I'll contact you somehow. I don't know how it works, but I'll contact you. Don't worry. We'll go from there. Okay, back to the Clanford clan. I'm going to close the data panel and just start with this blank canvas. So first thing I'm going to do, right click, new component. Very good. Now, this is kind of funny because it's asking, well, what do we want to actually create? And we're creating just a standard component, and the component name here is going to be our crankcase. My microphone is directly in the line of my keyboard, so there we go. I have to just feel it. Crankcase. Note this, activate. Activate will activate this current component. So if we go OK, note that it's now active. A lot of people miss that. You can activate the top level component and you can activate the first component. So that's what we're going to do. Activate crankcase. Our timeline resets. Again, a lot of people, they don't know about this, so I'm just going to go a little bit slow. If we activate the top level component, you see the first thing in our timeline is actually a created component, and that's the crankcase right here. Many others are actually pretty frustrated. They forget to activate the current component that they want to design in, and that's okay too. You just get used to it. And if you do make a mistake, there's some things that you can that generally tell you pretty quickly, oh, wait a second, I might have to back up a few steps, delete those last few steps and start again. So here we go. Looking at the crankcase, what would we start off with? Well, I'm going to pick a datum reference or a foundational reference that most dimensions are based off of. And if you look at the very top left view of the crankcase, it's the entire very northwest view of this entire paper, this entire sheet. That's what we're going to start off with. And you can see 12.7 millimeters from that one face. And then it goes to the left. And then we've got 11 millimeters that goes to the right. So that's going to be my datum reference. And what does that have to do with anything? Well, I'm going to pick this, our XZ construction plane, as that very same datum reference. So let's just click on that. And I can go in either direction. I could actually go in both directions. So let's go here. I'm going to start at the origin. And look at this. We are in inches. And this is supposed to be in metric. That's fine. Don't worry about it. So we're just going to find our... Here we go. It's supposed to be 6.5 millimeters. So I'm still in imperial. I'm just going to go 6.5 mm. There we go. Excellent. I'm going to pull that off to the side. Let's zoom on in here. Great. And actually we have 4 millimeters on the inside. This is looking great. I have to cough every once in a while, so I just muted the mouse or muted the microphone. If you heard my cough, let me know. Hopefully I didn't hear anything. So anyways, we're in imperial still. So at this point, I'm just going to skip on over to metric. There we go. Let's go okie dokie. And now we're all of a sudden back into, oh, this is centimeters. No, wait, let's go millimeters. Okay, so 6.5, perfect. And then what I'm going to do is I am going to save the through hole and use a hole tool. And again, I'll explain that in due time. But I'm just going to go to the rectangle center point and let's put in the total size of the entire primitive as I would look at this. So this is actually, the height is going to be 16 millimeters and the width is going to be 16 plus, actually 25 is the total. And you can see that dimension on the bottom left view. There we go. I'm just going to reorganize these a little bit more. Perfect. Let's define this a little bit more too. I am going to grab some lines over here. I'm going to do a center and I'm going to do another one over here. Beautiful. I'm going to turn this center line into a center line because now I can define this dimension from there to there. I could actually just pick that if I want. And you know what? If I do go from here to there, it's going to center everything, I believe. If it doesn't, that's okay. We can fix that. So this is going to be 16. Very good. Let's see if it automatically centered it. No, it didn't. So what we're going to have to do is just make a symmetric. So symmetry, pick those both and the center. Awesome. Okay, so that was just one extra step, totally unnecessary, but that's fine. Now, next we're going to do create an arc. Here's a little secret with arc, everyone. So if I go to center point arc, I'm going to go center point. Now here's a question. Should I start over here or should I start over there and wrap it clockwise, or should I start here and wrap it counterclockwise? Well, just remember everything goes in a clockwise motion. So if I start here and go this way, you can see that it will go from endpoint to endpoint. If I go the opposite way, if I start here, oh sorry, I should go there, start with the center there, and now look at, if I go from there to there, it's actually going to, do you know what? They fixed that. Usually it would create an entire circle around, so you can go either direction. Fusion has gotten smarter. Beautiful. Then I'm just going to define this from the center point over there, and actually I don't know if that is the center point. Yes, it is. We can prove it by means of that triangle, and we're going to do the same thing over here. And then I'm going to put these the mounting platform over here. Let's just move that on out of the way. First of all, I'm going to say I want these collinear because I don't want to add two dimensions. I don't want to add a dimension here and a dimension there. One dimension is fine, but collinear means they're perfectly in line. And then dimension from there to there, 2.4. Very important, expand your component, go to sketches. Sketches is completely constrained right now. Okay, here I'm just looking at the comment. By mistake, I made an imperial design in metric. Is there any way to convert it to imperial? I think all that you have to do is go to the document settings and switch it, and it will convert all those dimensions for you. So I think if that doesn't answer your question, keep on asking. Let's go to Bruce over here. If we accidentally don't activate it, create sketches under the top component. How do we move those sketches to the correct component? Let me show you. Okay, I'm just going to stop here and look at this. Now this doesn't work every instance, and I'll try and explain the why. So here we go. We've accidentally created that. Create sketch. Now here is where it might not make sense. I'm going to do it correct. First of all, I'm going to hide crankcase 1. I'm going to create it on this origin right here. Here's a question for you out there. This origin, what is it part of? Is it part of the top level origin, or is it part of its local origin, the crankcase? Well, it can't be part of the crankcase because the local origin for the crankcase is hidden. So this origin is actually part of the top level design. And as long as I create it on that, so look at this. Okay, I'm just going to create a square right there. And now look at this. In our top level component, if I expand sketches, there we go. I can actually drag this now and drop it. I should be able to drop it right into the crankcase. Okay, so that allowed me to do it. That allowed me to drop because I created this sketch on the global origin. Now, here's where you might get into a lot of trouble. I'm going to undo all of that. I'm going to create a sketch, even though I've activated my top level component, and I'm going to think that I'm actually creating it on the XZ plane, but lo and behold, I'm actually creating it on sketch 1 within crankcase. So this is where it will get you. So look at this. Okay, there we go. I'm going to create the same square. The sketches is still located right there, but look at, can I drag and drop? I can. That's too funny. Fusion has really updated a lot here. Okay, what I wanted to show you was that if you've accidentally created a relationship, and in this instance it worked, yes. There was a huge difference with what I just showed you, and it still is trying to explain a principle. So if I would have, let me just go back before I moved it. If I would have created a bunch of relationships off of that one sketch, which is actually relative to the crankcase sketch, then I might not be able to drag and drop it. But if you create it based with no relationship to the crankcase at all, then it will be very easy to drag and drop it. So I hope that makes sense. Simply put, I would love to get deep into that because it's all about relationships. What have you created the relationship on, and how does that, or to, and how does that affect the rest of your design? It's imperative for your understanding with Fusion. and to keep on learning. So stick with us. I really hope to dive into that a little bit more. But with what I just showed you, again, there's a huge difference where you've created that sketch. Some will accidentally create it. They'll think that they're doing it on the global origin, but they might be doing it on a completely different origin. And if that's the case, it might not necessarily let you, transfer your sketch or your body or whatever the case is. Okay, so let's just go back to our sketch. I think this looks good for what I want on this side of things. So I'm going to go finish sketch there. And now look at this. I'm going to extrude this. And do you know what I should have done? I don't like extruding to closed profiles. So I'm going to go back to my sketch and I'm going to convert this to a construction line. This is already symmetric. These two lines are symmetric to each other. So now this will be one closed profile. So that's what I want. I'm going to go there. And again, looking at our drawing, this is minus. A lot of you are frustrated out there. Which direction? Do you do minus or plus? Well, just grab the arrow. And now you can see this is a negative integer. If you go the opposite way, this is a positive integer. So I could just type right now if I want. I don't have to go the opposite way. Minus 12.7. That's what we want. Sketch disappears. Go back to the sketch. And now I can select all those other profiles that I've just made. Make sure to select the middle one. And we're going to go the opposite way of 11. Very good. And now I can hide that sketch. All right. So now we've got this main crankcase. Perfect. Now just go, once you have the main shape of this, I just go down the line what's easiest to do. If I have other sketch elements, I will sketch them first. Sorry, excuse me, I'm just going to have a little sip of coffee here. 99,959, everyone. Let's just see that for a second. Oh, it's going up. This is exciting. I'm excited. You know, it's not the biggest deal in the world, but it's just nice to share with you all out there. I appreciate it. And this is fun that you're sharing it with me. So anyways, let's go back here. So I'm going to look. Is there anything else that I need to do? Do I need to sketch anything here? I try and, again, do as many sketch profiles as I can to start off. And then move on to holes, tapped holes, large radii. Okay, that's a plural of radius. And then I very seldom use chamfers, but if it's absolutely needed, I'll put them on the 3D model. Very good. Okay, thank you. I think I tried everything but drag and drop. Okay. Bruce, thank you very much. Hey, if anyone is interested, welcome from Ukraine. This is great. Welcome, everyone. Anyone, if you're feeling like you want to keep us going and there's a little button there to buy us a coffee or to send us a little support, thank you very much. No pressure though. Don't even worry about it. Let's just enjoy this together. So what I'm going to do is I think that all of the internal details I would like to sketch. So let me do that again. Now I've created the top level component. I've done a bad job over here. And I've created those extrudes. And now look at this, everyone. If I drag and drop the body to crankcase, oh, what does it do? It creates another component, another feature in the timeline. So this is literally called a cut and paste. So even though I've dragged and dropped that body, I don't want this in my timeline. That adds an extra unnecessary feature. And in fact, if I activate crankcase, you can see my extrudes are not even in there. So I made the mistake. I'm going back to the top level. I'm deleting what I just did. It's not the end of the world. Activate crankcase. Do it right. Do it right the first time. Okay, there we go. Minus 12.7. We've already been here before, so this is easy for us. 3, 4. Okay, and this is going out 11 millimeters. Beautiful. Okay, simple fix. Now all of my features are in that timeline. Save it. Save often, everyone, in Fusion. It will keep a lot of hair on your head. Okay, let's see. We have another guest here. Excellent. Can you specify where you are referencing from? Is it the Motor Boys Members Only Plan Book? Yes, it is. And it is the Clanford Clan. I believe it's page 41 or 45 or 49 or something. It's in the 40s. So there you go. Hopefully that answers your question. Okay, so what I'm going to do is I'm going to do the internal profile here. Again, I'm hovering over the face right now. I don't want to. I want the YZ plane. So long click, pick the YZ. And here, look at this. I'm going to slice. Slicey slice. There we go. So now I'm looking at this slice down the middle. Don't be tricked here, everyone. You still can't pick this geometry. The geometry, even though it's split right now, or sliced, it's still, I mean, you can select on it, you can project it, but don't be tricked in thinking that all that geometry is automatically given to you. So if we want that geometry, press P for project. In this instance, I want to project the entire body, so I'm going to do that. And then I'm just going to hide the bodies. Okay, so this is the outer profile. If I change the original sketch, this projected geometry is automatically going to change according to it as well. So that looks really good. Now it's interesting, I do have an extra point here, and I don't know why that is. So it should be straight on through, but that's fine. We don't have to worry about that too much. I'm just going to define all this internal geometry right now. So let's go. Let's see what is happening here. So I'm just going to define it. Let's go up, something like this, something like that, over. And I'm going to go right to the center. Oh, I just bumped my 3D connection. Does anyone out there have a 3D connection? Space Mouse Compact? Anything? This I'm going to turn into a center line. Let me hear from you if you have any Space Mouse product fans out there. Okay, so this is my internal geometry. That's what it looks like to my eyes. So now I am going to start defining this geometry a little bit more. Now, believe it or not, we're going to call this diameter, we're actually going to just specify it as a thread in the future. So this doesn't actually have to be accurate. So, but what I'm going to do is I'm going to specify this as, this is a 11.5 millimeter screw cut, 0.75 millimeter, 32 TPI, right? So we've got all of that. I don't really want that. I want, yep, let me just find that correct dimension, everyone. Interesting. It doesn't actually look like that dimension is defined. That's classic. Okay, so this specific one, we're just going to call it as 11.5 millimeters. Okay, this one is defined. And again, because I've created a center line here, we can specify this as the correct diameter, and this is 14.7, and it will automatically create like it's a symmetric line on the other side. So 40 more to go. Yes, thank you for keeping your eye on it. Awesome. This back dimension over here, as long as it's, let me see. I'm trying to find that dimension and I cannot see it anywhere. So it's this dimension right here. That's what we want. As long as this is slightly less than the other, then we won't have any issues. If it's not slightly less, so I'm just going to pull this in, I'm going to reorganize them so it goes from smallest to biggest. If you have this overlapped, or some people go like this and they keep all these dimensions on top of each other, it's no good. Here you can see my dimensions are overlapped. I like defining this exactly the way it will look like on the drawing. So anyways, I go from smallest to biggest working out. Okay, let's go from there to there. And we're going to define this as 3.8 millimeters. And the next one from there to the front, 6.8. And then lastly, this is going to be 9.7. So believe it or not, these dimensions are actually down on the other side on the drawing, and that's fine. We could put them down there as well. The reason why I've retained it on the top is this is actually, if we look at the origin, if you remember the northeast, this is first quadrant, this is second quadrant. That's just mathematics, third quadrant and fourth quadrant. So I like to build in the first quadrant and define the dimensions in that first quadrant too. So here we go. I see from Michael, he's got an older Enterprise version, found it cheap secondhand. It's awesome. Yeah, I agree. I used to have the Enterprise. The reason I got rid of it is it's not fully functional with a Mac. So anyways, I just wanted to say hello to everyone out there, 20 concurrent viewers right now. Awesome. Awesome. If you're new, please tell us where you're from. We've got a ton in the chat already who are from all over the world, so this is great. Welcome. 33, everyone. 33. Okay, we might not even... I don't know. I mean, we're going to finish this tutorial because this is going to be fun for ones in the future too. But yeah, as long as this diameter is not the same as this, Fusion sometimes, if we create a thread based off of this diameter, if they're exactly the same, it's going to cut the thread all the way to this face, which we don't want. We just want this cut, right? So anyways, let's go to Finish Sketch. Now we have this. I'm going to go Revolve, grab that profile, and the axis is actually already picked because we created a center line and there's dimensions around that. So turn on the body, boom, cuts it through. Now here's a problem. Sketch 2 is not fully defined. This frustrates one so much to not have a fully defined sketch, but this saves your life. This saves you so much. And it's right here. I can just see that a mile away because I had a white dot right there. This just wasn't constrained anything. So to make sure it's constrained, I can pick it. Let's go to coincident, grab that center line, boom. This just is guaranteeing you, when it's fully constrained, that it's saying that everything is fully defined and it's the way you want it. There's nothing tricky, there's nothing hidden, there's nothing going to be accidentally moved on you. And that's what fully constrained is. Hi from Portugal and Austria. Welcome, welcome, welcome. Awesome. Let's go Finish Sketch. Turn on the body, make it visible. Beautiful. So again, this was one sketch profile. I don't want to add the thread yet. I want to keep on going and add the other sketch profile on the top here. And believe it or not, this is actually a counterbore. So why don't we, I think at this point we can start adding all the holes. Actually, what we could do is I am going to create one more sketch, create it on the mounting platform right there, the mounting, the mount where the mount goes. And I'm just going to add the screw holes, the bolt holes right here. Okay, so I'm going to make sure that this doesn't snap to the midpoint because we don't know if that's actually the midpoint. And you know what? We don't need to create them on both sides. We can just use the mirror tool to the other side. Okay, so let's do that. I'm going to turn that into a construction line, create 2 points on here, 1, 2. Beautiful, and then start defining things. So on this side, we have 21 millimeters, so it actually wants to go to the other side. So what I'm going to do is I'm just going to create a line, a reference line over here. And what we're going to do is I'm going to go D for dimension, and we're going to right click. No, not yet. Let's grab the center line. Let's grab this, and then I'm going to go right click and go diameter dimension. And this just specifies it from side to side. We could have also turned that middle line into a center line, no problem. Switzerland. Excuse me, I just had a cough there. Switzerland, welcome. Welcome, this is great. Constraints really frustrate me sometimes. I nearly spent an hour figuring out the problem. Yes, you're absolutely right. Now here's the thing, here's the quest for each of you. Get to the point where a constraint will save you your work in real life. You will see it sometimes that if you don't constrain, you accidentally move a dimension. Or actually, I can prove it to you here. Let me show you something. This is cool. I'm just going to go Finish Sketch. I'm going to create a new design just for fun. Let's go Part Design. And let me show you all something about constraints. So a lot of you have this grid pattern right here, and you can actually go to grids and snaps, and you can go to set increments, right? Okay, I want this fixed. I want them to be ½ inch from each other. But a lot of you will go like this. Okay, let's start off with the center, and I'm going to go up, and I'm going to snap to the grid over here, right there, 2 inches. Okay, I'm going to snap on over. I'm going to go to 2.1. Okay, I'm going to move this on over and go like that. Now, here's the fun thing. I'm just going to see, hopefully this works, because this is just a basic description of what's happening. I'm going to go D for dimension. And remember, I've gone up to 2 inches, but if I click on this, look at this. The actual dimension is not 2 inches. It is 2 inches, you know, with very, very small points, 0.0000638. Yes, but this is an example where it burns you, because if you don't have a dimension on there, a lot of ones will think, oh, this is exactly 2 inches. And in this instance, it doesn't really matter because it's such a small amount. But let's zoom on out here and see a little bit more. Maybe I'm doing something a little bit more beefy, right? I'm going to go on up here and go to 100. Boom. Okay, let's see how far this is out if I go dimension. Okay, so this is quite small as well. But yeah, I think you see the point that if you don't have a dimension, if you don't have it defined, then you might get burned with this, you know, thinking that it's a certain dimension and it isn't. Or worse yet, let's say we go like this. Okay, I'm going to zoom right on in, and I'm going to accidentally click off of vertical. But if I zoom on back, You know, a lot of people will think, oh, well, this line is vertical. It's perfectly 90 degrees going up and down. But in fact, it isn't. It is off. And if you're working with mold work or any other type of work, it could destroy your entire project. So anyways, constraints are fantastic. They're basically dimensions. They're basically dimensions that they don't have a physical number, right? Let's look at this. Where's the problem, everyone? Look at sketch 3. I don't have it fully constrained. Where is the problem? Can you see the problem? Let me know in the comments below. Where is the problem right now? Why is it not fully constrained? Okay, I'm going to keep on constraining this and see if you're right. Okay, so we're off of center mark here. So I'm just going to create another center to center there. Perfect. We're going to turn that into a construction line. This is off of the center. We're going to go to, what is this dimension? 3.5. And then from there to there is actually defined as 7. Okay. So what's happening? Why is it still not fully constrained? Does anyone know? Thank you. I've learned a lot from you over the years, says Studio Raddy Q. Studio Raddy Q. If I said that wrong, I'm so sorry. But white dot center line. Ricardo Martins. You got it right here. And look at how this affects my center line. So you remember I created a center line right there? If this is not fully constrained, then my center line is going to be off. And in turn, my 2 screw holes are going to be off. So what do we need to do? Coincident, this to that line. Boom. Everything is fully constrained now. So it guarantees that what you're doing is absolutely correct. Yes, everyone's doing great out there. Let's go finish sketch. Beautiful. So some of you might ask, well, why wouldn't I create all 4 holes here? Why would I just create 2 and then do a mirror over? You know what? It's totally up to you. I could have sketched all of those out and then just used one hole tool without the mirroring. Here's, I guess, the thing. When you use the mirror tool, it will define in your drawing that we indeed have 4 holes. In this instance, I didn't create the sketches over here, the center points for the holes, because I just wanted to show you something new. Okay, but in reality, I think it would have been best to have created the other holes or the other center points of the holes over there, because that creates one less feature in your timeline. And if I haven't explained this enough in the past, these are all calculations in the bottom. That's all that they are. So if you had a calculator in your hand and you had to input numbers, it's just one more step, and it creates one more problem for your computer. So slower computers will feel it more. Newer computers doesn't matter. But anyways, hopefully that explained it. Anyways, I'm going to pick those 2 points right there. Let's find our hole size. What does it tell us? Drill 2 millimeters through. So we're just going to go simple. Drill point really doesn't matter because we're going to say our diameter is 2 and our distance is going to be all. So it really, in fact, as soon as we go all, it doesn't matter about your endpoint. Flat, angled. There's a text command you can enter and it will show what's unconstrained. Yes. Yes, so actually if you go to, let's go to assemble. And do you know what? I barely use this. I've used it a few times, but I actually don't know where it is. I believe it's in Sketch. And we're going to go to constraints, and there we go, auto constrain. So if you're missing a constraint, you can auto constrain it. You can auto constrain from datum as well. So datum again is a measuring surface. If you actually had this physical part in real life, you know, getting into engineering and datum references and datum surfaces and points. I would love to get to this point with the Learn It channel. So if you're interested in learning about datums, hopefully I'll get to it at some point. But let's hear it. Let's hear it in the comments section. Datum. Okay. But some people call them datums. Yeah, whatever. It's all good. So anyways, you could do that as well. No worries. Okay. Actually, let's try that. Let's go back to sketch 3. I'm going to go to this point. I'm going to delete that constraint. So this is where we were. And now let's go back to constraints, and auto constrain has shown up. So let's go auto constrain and see what happens. Let's see if this actually works. No, it does not. It does not. So we can go, we have a couple results here, but it's not, it doesn't understand that this is just a center line. Okay. So anyways, coincident, boom, bada bing, bada boom. Datum, Tom Mole, awesome, datum. Okay. So anyways, we've got our holes on that side. I can just simply go to create mirror. If I haven't shown this already, everyone, S, search menu, mirror. Yeah, I don't say mirror, everyone, I'm just having fun. Mirror. Features, and just pick it in your timeline. Holes, mirror plane. Okay. Again, I want a long click because I want the YZ plane. Beautiful. Identical. Awesome. So now in my drawing, if I reference these holes, it will say that there's 4 instances of them. That's the whole point of the mirror. Mirror. Oh, and no. I have misled you all. I have misled you all now that I think about it. Oh boy, sorry about that. Mirroring creates completely new features. So it actually say 2 instances and 2 instances. So I do not want to do that. What am I doing to you all? I'm sorry about that. Okay, let me show you a couple of neat things then. I'm going to create another line over here. Did you just see? I could not reference that edge. Okay, so I'm going to go, yeah, here. Let me show you one other thing. It looks like it's snapping here to this edge. It is not. It's snapping to the grid point. Okay, snapping to the grid. So I'm going to go P for project features this time, and I want to grab this geometry. I want to work with that geometry. So project it first. Create your line. Look at this. Symmetric. I've already defined this line. I'm just going to make them symmetric, and it will actually automatically make those lines exactly the same. Now, X, I could have also done this. I could have gone mirror, and I could have picked that line. In fact, why don't we just do that? Okay. I'm having fun here. 1, 2, 3 features, mirror line, pick the center. There we go. Everything is fully constrained. Excellent. It's the exact same thing. Go back to our hole tool. Awesome. What are we at? 9997999. Whoa, 99981, everyone. Awesome. Awesome. I'm excited. Is anyone else out there excited? This is fun. I'm just a regular, ordinary guy, everyone. So having everyone here join, this is just a blast. And yeah, I would just would love to hear from you. This is fun to celebrate this together. Okay, cool. So there we go. Now, I will not mislead you. In my drawings, this will actually show a reference of 4 features. So there we go. Excellent. Let's move on here. This is taking forever. Let's pick, okay, let's pick this as our counter bore. So what I could actually do is I'm going to exit out of that. I don't even need a sketch profile over here. I can create a hole. I'm just going to create it right on this face. And as I move the hole, it will bring up snap points. Okay, so I can snap it to all sorts of things, but the center point is what I can snap to. I'm going to do counter bore. Doesn't matter here, flat. Yeah, it doesn't really matter, but let's just go down the line. How deep do we need to go? I'm just going to pull this down for reference. Okay. And then let's go to our counter bore diameter, which is 8.5 millimeters. How deep is it? 7.2 off of this plane. 7.2 off of that plane. So I think what we can do, no, let's just do the math here. Okay. So 7.2 off of 8, so it's actually 0.8. Okay. And then our through hole is going to be, where is it, everyone? Through hole, oh, there we go, 7.5. Really excited, awesome, really excited. Could you mirror the sketch and then make all 4 holes? Yes, that's what I did in the end. Excellent thinking, Ricardo. Very, very good. Very, very good. Now, here's just a little bit of help. Like, how far do you go down with this? We can't actually select 2, I don't think. We could pick this face, that face, and the other. Oh, there we go. Yeah, it does go all the way through. Excellent. I think that's the way to do it. Pick the surface that's the smallest diameter. But if we were to manufacture this and we were to be using an angled, like a regular drill bit, then this is actually very helpful. If I go distance, I need to pull this through so that the drill point just breaks right through that surface. And then at this point, I can even bring that back. Then on my drawing, it will actually show the distance that this drill needs to go to. And this makes it very easy to define in CNC programming to say, okay, I want it based off of this datum reference, this face. I can go 4.2 millimeters deep, and that won't hit anything else. Let's say that this is a lot smaller diameter, and going an extra 0.5 millimeter is critical. It will hit the other side. Well, this tells, the CNC programmer, you can go to 4.2 and you're safe. You will break through, you will cut through that surface. Everything will be great. Okay, beautiful. All right, what are we at? 99978. Awesome. Any other questions out there, everyone? If you have questions, hopefully I've got the answer. And if I've missed something already, if you've already put a question down and I've missed it, well, yeah, let me know. Let me know again. Don't feel shy, everyone. Again, I'm just a regular, ordinary guy with mistakes galore. So, anyways, yeah, let's have fun. Having more coffee. Beautiful cappuccino to be to be precise. Okay, so anything else? And this is what I want you to do too. If you're not already in the routine of this, and if you haven't been marking off everything, well, I'm going to do that right now, and I should have been doing that all the way around, along. But mark off all your dimensions, everyone, so that you are verifying to yourself that you have not missed anything at all. Okay, so I've got most everything here. 8, 16, beautiful. 16 millimeters, 12 are those, which I don't have yet. 2.4 I have. 6. Oh, I haven't done the through hole, so let's do the through hole. Okay, so again, I'm going to create the hole over here. Bada bang. Just move it off to the side, and then it will snap to the center point. Great. Let's just go simple in this instance. Let's get the hole on the inside is 4 millimeters, and then distance we're going to go all. It's going to go all the way through. And again, what's the significance of all? Well, there's many practical applications to it. But basically on your drawing, it's going to say especially if this was a complicated hole, that's the brilliant thing about drawings, is that you just create a note and it defines all of that information for you. Thread data, counterbore data, countersink data, all of the angles, everything, diameters, everything that you need to know with one click rather than having to define all of that. But one of the things that it also will say is it will say through, THRU. That's on an official drawing saying that a hole goes all the way through your part. Okay, very cool. There we go. What else do we have? Well, I guess I could have put the other sketch data over here. So I've got that sketch data. What I'm going to do is, let's just put it in now. It doesn't really matter in this instance. Put the sketch data there. I'm going to reorient this as I see it on my drawing. Okay, so let's create another center line reference. Okay, in this case, it has been fully defined. Here I see a question or a comment. I've been trying to learn SolidWorks from scratch and finding Autodesk awesome. I'm a beginner looking forward to learning this and I'm really aspiring to do this as my career someday, if you don't mind. Absolutely. I encourage it 100%, 100%. I'm loving this, everyone. And it, you know what? If you haven't heard my podcast, my first podcast about how I even got into Autodesk Fusion, my experience goes all the way back to when I was 12 years old. I'm not going to get into the whole thing. So if you haven't seen it already, make sure you have to be a paid member to listen to those podcasts. So if you're interested, it's a fantastic experience that I was able to have, and I wanted to share it with you. But to go into a shop and really do something that's impressive to your employer. Not that we're always looking to impress our employer. It's nice when we're able to, right? But when I went into the shop and I was able to say, do you know what, the part that you've been spending month on, 2 months on, I can get it done in 30 minutes or an hour. And the boss is like, what? Yeah, Autodesk Fusion, and SolidWorks works just the same. It's fine. Any other NX, Siemens, Mastercam, all of these programs, they're just different languages. Everyone, there's like programming languages, and some of them do, more than others. But now, let me just look over here. When is the SolidWorks video dropping? Everyone, I have good news. It's probably going to be I hope to have 2 SolidWorks videos dropping in June. Okay, so hopefully you don't hate me for going with another software, but we love teaching on this channel. And there's a lot out there that are interested in learning SolidWorks. So, you know, if you're considering becoming a member, I have a SolidWorks Patreon page, which all of those additional exercises, all of the videos, ad-free, and all of that are going to be on the Patreon site. It's 50% off right now. I'm going to flip the switch at some point. We're going to go, 100% cost for membership soon. But right now it's 50%. If you're interested, this is the time to sign up, and it will be permanent for forever at that price that you're paying. As long as you pay that price, right? It will be that price, which is really a good deal. So anyways, 99979, everyone. We've got 21 left to go. This is exciting. This is great. Okay, so I've just created a center line over here. Let's create a point. Okay, point. And what I can do is I want them symmetric to that center line. That just helps to define it. I don't need to say that all dimensions need to be defined, because these, now if I say this is actually right at the midpoint, so believe it or not, because this line spreads from mid to mid, I can just create another point. Oh, I thought I clicked the midpoint there. I didn't, so I'm just going to click the point and the line. Midpoint, excellent, and I'm going to go vertical. So there's nothing here that tells me, if I look at it quickly, there's no dimensions on it, but I look at the constraints and I see that this point is constrained to the center of the line, as long as this line is constrained to those outer profiles, and this is vertically constrained to the center point, then these are also perfectly centered. The one thing that isn't constrained is this dimension, and again, because they're symmetric, you can see the little symmetric icon. Excuse me while I cough. It's also the exact same when you mirror something, it comes up with a symmetric icon as well. So anyways, you've got that. Now all we need to do is put in our dimension, and this is 12 millimeters. Awesome. We're getting more hearts over here. I really like the podcast and loved learning about your journey, Ty. Tom Mole, thank you so much. That's great. Again, I'm just a normal guy, but all of us have stories, and all of you have stories out there, and it would be a blast to hear your stories too. But it's just neat to be able to share that with you, in a way to encourage you with Fusion, that you can have a career out of this. You can make a run out of it, and even if you have a YouTube channel in the future, make sure to send a shout out to us every once in a while. All right, let's go finish sketch. And we are going to add our tapped holes here. So let's do that. Go to the hole tool. There we go. We're going to go to tapped. And here, we just don't want to go all the way through. So what size of hole is this, everyone? It's a drill tap 9BA. So I'm going to go to Mr. Google and say, tell me the equivalent to a, what is this, 9BA tapped 9BO threaded hole to metric. Okay, just type that in, and what does it say? It is basically, the closest metric equivalent is an M1.6. Okay, let's see if that even looks like it's right. So size 1.6. Yeah, that's it. Okay, so that's the closest equivalent, everyone. This is going way too deep. We're going way too far. So again, I'm just going to use the, in real life, this would be cut out with a drill, okay, and an angled point. And this, if I go to that dimension right there, on my drawing, it's going to say from this surface, you can go 6 millimeters down without it hitting anything. And that's what I want. That's when it will break through. That's when we're good to go. Okay, beautiful. Do I have everything, everyone? Can you verify I have all my dimensions? For those that are just tuning in, make sure to download the plan book. The link is in the description to this video, along with other links that you might enjoy. So there we go. Everyone, the crankshaft. Oh, it's not done yet. We've got the fillet over here, not the fillet, everyone. That's for fishing. Save the fillets to the very end. There we go, 2mm radius value. And everything else has been fully defined except for, as I see, one other thing is this value right there. So again, this is defining it as 11.5 millimeters. So if I go over here to create and go to thread and grab that right there, this is saying it's 11 millimeters. We can't actually define 11.5. So what are we going to do? I can go 12 as well. All that I want to do is I want to make sure that it is going to be bigger than this back surface over there. So let's go to 14. Yeah, 14 is fine. Okay, we can always change this later in the future. And this is saying that it is 0.75 millimeters. So let's go metric 14. And look at how big this is now. Oh, it's much, much larger than that. So let's go back to 12 and go to 0.75. And now if I go to the back view, you can see that this other dimension, this other diameter is slightly less than this, and that's what we want. That's basically what the engineers are looking for. Now this has to clear the counterweight. So whatever the counterweight is for the crankshaft, that's what we want. Awesome. Everyone, how we're doing? 99980. Beautiful. Okay, good. So now as we save that, all of the features that we've used to create this particular component are all located under our component, our first component that we created. Our first component we created is also grounded. What is it grounded to? If we hover over it, it tells us it's grounded to the Clanford clan. So that's to our top level component. That means if I click and drag it, I can't move it. So excuse me as I cough again. Okay, I'm back. Everyone, 99981. This is exciting. 24 viewers right now. If you haven't told us where you're from yet, please let us know. Again, everyone, I'm going to pick a random commenter out there. Anyone who comments, I'm going to pick you randomly, and I'll give you a gold membership for our Patreon channel for a year, Patreon page for an entire year. So anyways, there we go. Great. Now it does have a chamfer that's defined on the back of this right here, and that's important because our crankcase needs to have a little relief for its fillet, or I'm sorry, the crankshaft has a fillet in it that will mate up with these two surfaces, so there needs to be a little relief there so they don't interfere. So at this point, even though in real life this is going to be completely deburred with chamfers, I don't want to define all of that because then my drawing gets extraordinarily hard to see. I just want to put on my drawing that we have a typical or break all edges at a certain value. But this is important, 4 millimeters, and it does say chamfer 45 degrees. It doesn't actually specify how big this chamfer is, so I'm just going to call it 0.5 millimeters for now. We can always adjust that in the future. Great. Okay. Come on, subscribers, 99981. Cool. Okay, next component. When I look at this sheet 1, again, the crankcase is completely done now. I'm going to do the back plate, and we're going to mate that right here, after which we're going to create the fuel tank as an entire subassembly. So before we do that, again, instead of going create and go to create new component, which you can actually not do that anymore. Fusion is always changing. It's always changing. So I'm just going to go to our top level, and then I'm going to go new component. Do I go assemble? Ah, it's under assembly now. New component. Yeah, there we go. Okay, very good. Very, very good. So component name. This is going to be our back plates. Excellent. Oh, we're getting congratulation bouquets over here. Thank you, thank you, thank you. This is exciting. Okay, backplate, everyone. Once a backplate is selected, I have a couple options. I can start building it off of this face. If I do so, it now creates a relationship to that face that makes it very difficult to change in the future. Sometimes I want that, sometimes I don't. So I don't want to create it off that face. I want to hide the entire crankcase component, and I want to start from scratch. So there we go. I'm going to pick the X Z construction plane, and I want to build it in the same direction as my original construction plane. So let's do that. Here we go. Again, this thread dimension. And do you know what we should actually do? Instead of creating circles here, I'm going to go undo everyone. I'm going to create the side profile instead. So let's do that instead. Okay, I'm just going to create the outer extremities of this back plate. So again, pick this line. I'm going to call it a center line. Let's go D for dimension. Put the outermost extremities to our part. So this one is 15.5, and then our dimension here, I can just pick that right there, is going to be our total value of 5.5. So this is the entire extremities if we consider it to be revolved to the other side. Okay, I'm going to move these in now that the perspective is right, or the scaling is correct. Now what I want to do is I want to define my thread. There we go. Okay, here's a quick, really cute, cool thing with chamfers is I'm going to go to perpendicular, and I'm going to define both of those right there. Oh, they're actually already perpendicular to each other. Okay, so that just means that they're 90 degrees. And if I define, yeah, let's see here. Does this need to be defined as 45? Yes, it does. Okay, so we're just going to do that. Perfect. Let's go to our dimension here. It was a 12 millimeter. And see now that first chamfer has disappeared. So I'm just going to go undo that. I'm going to pull this on down. There we go, 12. Awesome. Okay, and what is this? The thread is 0.75, so at least from there to the chamfer, if it's at least 0.75, then we are good to go. So if I go 0.8, right? And here's a neat thing. I'm just going to go to vertically constrained from that point to that point. That's fine. And we have 0.8. This dimension right here is going to be 0.8. And then our final dimension from there to there is going to be 1.5. Hello from Longbridge, Birmingham. Oh, what have I done here? 0.8. Awesome. There we go. So now you can see that's defined, and I can actually also put that right there. This is the chamfer 45. It says the screw dimension 10.5. So this dimension right here is 10.5. It cannot be 10.5. Interesting. Interesting. So then this dimension right there. Oh, I don't want to go 0.8. Yeah, let's not do that. Okay, and I really think that this is going to be too much. 12 there. Oh, I see. Okay. So if I just call that 11, that should be fine. And then the depth here is 4.5. Anyone else there that wants to say hello? We're at 99985. Everyone, 15 subscribers, more to go. I'm just gonna go right on over there. There we go. Oh, this is exciting. Thank you all for taking the time to share this with me. That's great. Okay, this is probably too slim there, but that's fine. Yeah, let's go finish sketch, and we can go revolve. Perfect. Axis. Sometimes it doesn't pick it. Anyways, there we go. That looks about right so far. Is this 1.5 for sure? So shift select both those faces and it shows you in the, no, this is 0.8. That's wrong. So I have to go back. This value is 0.8. This needs to be 1.5. There we go. All right. Beautiful. Let's go to create sketch. And here all I'm going to do is create a rectangle, center point rectangle right at the origin. I'm going to move this off into space and just start defining it. So the slot width is going to be 1 millimeter. And then all I'm going to do is go to tangent and say, okay, I want this to be tangent to that outside edge. And then it makes sure that it cuts through everything good and nice and good. And then I can just extrude. I could just extrude those individual profiles right there. And these go in, it actually doesn't say, but it looks like it's just going in -1. Okay, beautiful. Create a thread right there. It defaults to 12. Remember, at this point, it doesn't really matter what dimension we put there because I could actually define it as 14. All sorts of different things. The chamfers matter, right? But let's go back to 12.75. Okie dokie. Do we go to cosmetic thread type or modeled? If we go modeled, then all of a sudden we see our modeled thread here. Oh, and do you know what? No, this is no good because the thread doesn't go all the way through. So I'm going to go back. I'm going to go back to that sketch, the first one. And I actually don't want, what's happened here? We're totally flipped around. There we go. That's hilarious. It's completely flipped around on us. I don't want these chamfers. Okay, so I'm just going to delete them. Boom. Okay. And I'm going to just go like this. I'm going to go from that point to that point, but I want this to be vertical. And then I'll put the chamfers on later. Okay, we're going to do that. And then I'm going to go coincident from there to there. Okay, there we go. Now you can see that the thread goes all the way to the outside of our part, whereas before it wasn't, right? So at this point, we might ask, well, how do I put the chamfers on there? Well, we have to go back to cosmetic threads. Okay, beautiful. And cosmetic is mostly used for doing drawings and everything. Manufacturing in general, you never use, modeled threads. That's mainly used for 3D printing and stuff like that. But at this point, I can put modify chamfer. Okay, I can put them on there. And what was it, 0.5? No, 0.4, 0.45. That's what I had. There we go. So now, since I've got the chamfers on there, I can go to modeled. Beautiful. And now we've got this beautiful thread all the way there. But if you don't do it that way, if I try and put a chamfer on at this point, or before I've chamfered, like after I've created the modeled threads or adjusted it to modeled threads, there's no way you can put a chamfer on there. It's impossible. Okay, so that's what we want. Let's go back to cosmetic. Beautiful. Any other new viewers out there? Welcome, welcome everyone. This is all live. First live show I've ever done. So welcome. There we go. Excellent. Let's save it. Now the back plate, have we checked off all the dimensions? I certainly hope so. I hope you're following along. If you're looking for the plan book, everyone, make sure to head on down and get that plan book. Okay. So I could have put the chamfer in there as well. It does say it on the drawing, chamfer 45. Why don't we do that? Yeah, why don't we just call it a 1 millimeter chamfer, something like that. What do you think? That looks alrighty. Let's do it. 1 millimeter doesn't really matter if it's not defined on the drawing, as long as it's not gigantic. Okay, let's go back to the top level component. Make the crankcase active. Here we've got a component nestled within a component. I'm just going to drag and drop that out to the side. Assemble, joint. Grab this face. I want this face to be mated with that face, and I want them centered to each other. So basically what I'm going to do is grab that face, and then it will snap to the midpoint. There we go. Do the same thing. Click the face. Don't click on one of these joints. Click the center point. Boom. Look at that. Okay. Let's make everything right, everyone. I am going to go over to the, what are we at here? 99985. Beautiful. Expand relationships, expand joints. You can see if I hover over that joint, it says it's a rigid joint between back plate and crankcase. If you get more and more of these, I like to specify it by renaming it. So back plate to crankcase. Remember this to that, everyone. Who remembers our early days of whiteboard animations? This to that, right? But basically this to that, back plate to crankcase. In English, we don't say that to this. Okay, so there we go. Now we can hide that when we have 100 different joints at the end here. We know exactly which one to click and what to edit. Beautiful. Let's keep on going. Let's keep on going. Let's make sure to save. Now, here's the thing. Again, when we look at that sheet 1, you can see that the tank top, the entire fuel assembly, this is basically what it's called. I would like to call it the fuel assembly. And basically, we're going to create a sub-assembly here. So let's go to new component. Okay. Component name, we're just going to call this our fuel tank assembly. You can see it's a single component right now. That's fine. With it being a single component, all we have to do is right-click and go to new component. And it will create this. It will turn it into a sub-assembly. So what's the first thing we should design here? I'm going to say the tank top. Beautiful. So now you can see the icon has changed for the fuel tank assembly. Now it's an assembly. And then we have a grounded, or it's linked to the fuel tank. This will still be able to move. But if we ground the fuel tank, then nothing will be able to move, right? But just because this is grounded, this is actually grounded to the fuel tank assembly. It's just saying that this will stay put within the design, your design intent with fuel tank assembly. So let's start off with that tank top. Right-click, isolate, gets rid of everything on the screen. Let's go back to ISO view and start designing the tank top. My voice is starting to get hoarse, everyone. This is I haven't done recordings actually for quite some time, but I'm super busy with life and just haven't been able to. So let me just see. I have a plus here. Engage with your audience. Oh, start a poll. Okay, everyone, here's a poll. This is just going to be fun. Do you prefer, and what is it? Let's go to preferences. Dark blue theme or light gray? Do you prefer? Which theme do you prefer? And we're going to put this in here, dark blue. Or, what was it again? Light gray. Oh, and it's gray spelt with an A instead of an E. Start poll, everyone. All right, let me know. Let me know what you think. The poll has started. Okay. Let me hear your vote. Oh, dark blue. Instantaneously, it goes to 100%. Oh, no, down to 67. Amazing. Oh, back up to 75. This is hilarious. I mean, I guess it's not the big... Oh, we're jumping around a little. I just need a second to let my voice rest here. Have another sip of coffee. We'll see how that poll goes. Ah, dark blue, always better. Less strain to the eyes. Ah, yes. But here, what's the difference? Let me ask you here. What's the difference of going into your display settings and going to environment and selecting like Tranquility Blue or something like that? Do you like just the dark blue in general? Or, yeah, let's go to theme. Because even with dark gray, or dark blue, I should say, I could go to the environment and say, okay, I want photo booth. And then, everyone's eyes are fried. Oh, no. Okay, all right, let's go back there. Sorry about that for everyone who loves the dark blue frying your retinas just now. All right, let's move it on. Tank top, everyone. Again, how do I even go about this? Well, I have to pick a primitive first. What's the basic shape of this? And how can I move on from there? So I see two basic shapes here. I see a round bottom shape, a cylinder, and then I also see a rectangular prism as well. So what would you want to start with? Well, it really doesn't matter. I'm going to prove it to you. I'm going to start with the cylinders. Okay, so let's start there. I am going to go to our outside diameter, which is 12.5. Perfect. Let's drop this on down in the negative direction, and this is supposed to be, let's see, our datum reference makes more sense, but this is 1 millimeter. No, it all makes sense. There we go. Okay, let's go 1. Let's do another sketch on the bottom. This is going to be the secondary dimension. And what is this? 10 millimeters. Okay. this also goes down 1 millimeter. Okay. Beautiful. So that's the bottom. That's kind of the primitive shape that I'm starting off with on the bottom, right? But let's create a, I'm just going to rotate this so that it's accurate in the direction that I want. And here I can do a 2-point rectangle and start there and start defining these dimensions as well. And actually, you can see it's not based off of the center point right there. So I'm going to delete that center rectangle. And here I'm just going to create it off into space. Don't snap it to your origin because those are two different center points. So I'm just going to make those horizontally constrained. So now this has to be in line. In this case, this is the y-axis because I've rotated it 90 degrees. But D for dimension. And we're going to go to, from here to the center is going to be 7 millimeters. And from the center to the end point there is going to be 6.3. I hope you've downloaded the plan book, everyone. Go ahead and download it if you haven't already. Okay, done. And 1 millimeter there. I'm checking off everything on the plan book that I have. Perfect. So now I've got that primitive. Here we go. We've got 3 closed profiles. How do I fix it from 3 closed profiles? Not that that's the biggest deal, but I could always go back to the previous sketch. And then look at this. Because I've created the sketch on this face, it's automatically inherited all that geometry. So all I need to do is go to the outside and turn it into construction line type. And now this is 1 closed profile. So I kind of like that. Doesn't really matter. Okay, and now we're going to go up. And how far do we go here? How far do we go? So, all right, so this is what we're going to do. I'm going to bring this up into space. And look, here's a little trick that I love. Click on the kebab menu, everyone. This is the kebab menu, up and down, re-anchor. And you can see that it's actually definable by the center point. So 3.3 to the bottom of this face. So I'm going to re-anchor it right to there. And then I can actually specify this as 3.3. Okay, that goes to the center point of that feature. Okay, and then what I can actually do is create a sketch on here. And this now, if I create a circle at that center point right there to there, this is exactly what we're looking for. And I can grab that and go to object. And I want to extrude. Oh, hold on a second. Oh, it's my start. I'm sorry. Let's just go cancel, repeat extrude, distance. We're going to go to object and we're going to go right there. So basically that's what we're looking at so far. Very, very good. Yep. Okay, now let's go to create, and I am going to create it again. And I guess I could create, I have 2 options here. I'm going to create it right on the XY construction plane. And then here, I'm going to create these 2 diameters, which are what, 4 millimeters? Okay, I obviously didn't define something. If I expand this and my sketches, yeah, sketch 3 isn't fully defined. This dimension right there. Okay, if we look at our drawing, what is it? It's the same as that dimension, 4.5. Beautiful. That looks a whole lot better, and now you can see the sketch is constrained. I knew something was fishy. Okay, 4, and then we've got, let's just extrude this. Okay, it grabs that last one, we can go up. And this is 3.7 based off of the center point. So what we can do is, again, we can go to right click, re-anchor, and can we, no, we can't pick that one. So let's just do a little bit of math here, everyone. Actually, yeah, we can go re-anchor based off of that. Okay, sorry, re-anchor off of that face. Okay, we want to go up 3.3 plus 3.7. Okay, And then we're going to, we don't want this to cut, we want to join. Oh, I just found the dark blue theme and loving it, Baru says. 99987, everyone. Beautiful. Okay, so this is looking a little bit better. We can define this as well. Let's do a center point circle right there. And this diameter is 3 millimeters. Okay, E for extrude, everyone. Grab that profile, move it on up 1 millimeter. Okay, we're slowly defining this shape. This is looking great. I don't know how they did this in real life, but I think in modern day you could probably just, 3D print this. That would be fun, eh? Okay, let's keep on going. What am I missing? Are you checking off everything, everyone? I hope so. I hope so. Okay. I mean, if I'm failing to do it, not saying that you would be failing as well, but yeah. Oh, that's the fuel tank. Okay, cool. Okay, very good. What else do we have? Let's go to create a sketch over here. And the center point, this tells us what do we need to do? Thread 4BA. So we're going to go back to Mr. Google. Tell me the equivalent of a 4BA. Threaded hole to metric is approximately 3.6 millimeters. Okay, so let's just do that. Here, it should find the center point of this, or concentric, right? Concentric to this arc, and there will be a little circle right there. If you can't find the circle, don't worry, go off to the side. Okay, we're going to call this 3.6, and then look at this, concentric, pick the circle, pick that arc, and it perfectly places it. Okay, so concentric is your friend. Great, this moves on over 6 millimeters. Now we just have a couple holes, I reckon. We've got a drilled hole through it. Okay, let's put our holes in first. And do you know what I'm going to do actually? Yeah, I'm going to put this hole on the other side. So right click, repeat hole over here again. If we move this on over, now we've got 2 holes to choose from. Oh no, which hole is it? Well, one of them is the center of the face, and the other is the center of our arc. So I believe it's that. Yes, you can see it's lined with that. Perfect. Okay. And then what I'm going to do is I'm going to call this a countersink. We're going to go all the way through. It's not going to be tapped. It's going to be simple. Okay. But what I do want to do is this is supposed to be what? 5 degrees. Okay, so 90 degrees is like this. So we want to go the opposite way. So if we go 10 degrees, just like that, that's 5 degrees on either side. And the through hole, drill number 54. So I'm going to go back to here. Number 54 drill. Okay, I'm typing that in Mr. Google on the side here is 0.055 or 1.4 millimeters. You know what? I'm just going to call it 1.5 millimeters. Be done with it. Okay, and then the taper has to do with this outer dimension. So if I grab that, I can actually make that a little bit bigger. And in real life, the taper goes right to the midpoint of this right here. So I think that's probably a good... There's no perfect dimensions on this, like it's not specifying the exact depth or the start diameter. So because it's not perfect, I'm just assuming that its endpoint of this taper is right in line with the center of our part, which this is just an approximation right now, not a big deal. 99988, everyone. Awesome. All right, this is fun. Okay, let's create another hole on the top. This is just going to be simple. We're going to go all, and then the through. What is this? This is actually tapped. This is an 8BA. So I think we had the 8BA already, right? 1.6 millimeters. Yeah, so we're going to go back to tapped, and we're going to go to, what is it supposed to be, 1.6. Very good. And now what I can do is I'm going to go to and select this inner. Oh, it doesn't let me select it. That's fine. So we're going to just go to distance then and grab this. And this is the instance that I was talking about, that if this drill goes too far, it's going to cut into the other section right there, right? Which we don't want. We just want to make sure that we cut the hole, that this is completely threaded. Beautiful. Create thread there. And what is this supposed to be on this side? Oh, that's supposed to be the 4BA, right? So that's supposed to be 3.6. We're at a 3.5 millimeter right now. 3.5 is fine. And our pitch right here, 0.6 is fine. All right, so I think that looks great. I'm just checking off all of our dimensions. Oh, we're missing a couple holes over here. Okay, so we're missing one on this side. This looks like where we put the fuel in. So I'm going to go to create a sketch right there. And actually, we don't even need to create a sketch right there because we've already created a sketch at the very beginning. So let's go back to that. And now we've got a couple of the, this is kind of funny here. We're going to create the 2 millimeter. I'm going to say that this is vertical to our center point. And then I'm going to go and create another diameter circle because this is actually, it looks like the two endpoints are tangent to each other to the 10 millimeter. So what I'm going to do is I can just create a 10 millimeter circle right there. And then I'm going to say I want these both to be tangent to each other, and it will lock it in. Okay, so that's what we want. Perfect. I am going to call these construction lines, line types at least. Make sketch 1 active again. There's the point that I'm working with, and at this point I can just call this our hole. So straight on through to, what are we at everyone? 99989. All right, and this is going to go all the way through. Perfect. And there's actually a little breather hole on the other side, and it doesn't look like it's defined at all, but it's along the same center location as the other one. So I'm just going to go back here again. Let's create one more diameter circle, center to center. There we go. Okay, create, and we're going to create one little point over here. Let's create it right there, and I'm going to make this horizontal to the center, so that's perfectly constrained. Okay, cool. And let's go to hole. I'm going to put a hole right there, and this is going to be a 1 millimeter. Again, this isn't defined on the drawing, but I believe it's a little breather hole. Perfect. That's what we want, and let's hide that sketch. Okay, cool. So this is the tank top, everyone. Am I missing anything? Does anyone else see anything else that I've missed? I don't think so. Okay, I'm just checking off everything here. Beautiful, 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 beautiful. Okay, cool. So one other thing that we're actually, I am missing is the hole for the brass tube on the bottom. So let's create a, using the hole tool here. And again, which one are we looking for? Well, in this case, it's the bottom one. Okay. And this is going to go all the way up here. And again, this is for manufacturing's sake, how deep that drill point goes. Is this perfectly located? Yeah, it is perfectly located. Cool. Okay, so then this is going to be a straight, simple, simple, simple. And our brass tube is 1 millimeter OD. That's fine. Great. So that's all we want right there. Cool. Let's save it. We're almost there, everyone. We're almost there, 99989. If you haven't subscribed already, please subscribe. We'll quickly get up to 100,000. But don't worry, I'll keep on recording. Beautiful. Now, tank top is done. Let's go back to our fuel tank assembly, right click, and we're going to create a new component. And this is going to be our brass tube. Excellent. And now what I can do is we can create I'm just going to create it off of this face because it's all within context, right? And then because I've created on that face, again, I can define this. This is going to be 0.5 inside diameter. Extrude, we're going to grab this, and here we're going to go two sides. So the first is going to go up to approximately there. The needle valve is going to come through the top. We're going to go 3.5 millimeters up and then go down 13. Beautiful. Now this kind of leads me into something we've been forgetting. I'm going to activate the top level component, make all the components visible. Well, maybe we'll hide the, we've got the spinning wheel of sudden death here in Mac world. No, that was close. Save it again. Whenever we see that, we save in Mac. Okay, there we go. And we're going to go to our fuel tank top over here and go to physical material. We look at this and it says black plastic molding. So I'm just going to go to plastic and let's see what we've got over here. They've got all sorts of different plastic. I'm just going to do a regular plastic opaque black. Okay, there we go. And then we're going to go to, and we can actually search here for brass, right? Soft yellow. Put that as a fuel pickup line. And then let's make our other components visible over here. And what are these? We've got 6061 aluminum. Okay, let's drag and drop that. And then our back plate is also aluminum. Instead of just defining it as standard aluminum, oh, and it says clear anodize on the 6061. Okay, that's fine. We can just put 6061 on the other piece right there too. Great. All right, everyone, let's go back to the fuel tank assembly. Right click, we can isolate it so it hides everything else. And what do we add here? Let's add the fuel tank. Why not? Okay, so new component under our fuel tank assembly, and this is going to be our fuel tank. Perfect. Let's create a sketch. I'm going to create it just right on this face right there. And then we're going to go over to the outer diameter of our fuel tank is 12 millimeters. Great. And now you can see we've got this entire profile right there that we can bring on down. This is supposed to be 17 millimeters. Great. Now there's a couple ways to make this a little bit faster and better, but basically I'm just going to do this. This is super easy to do. Isolate it. I'm going to click on the inside and just delete it. So now that it's a cylinder. At this point, I'm going to add the fillet to it. And again, this is 12 millimeters. So if I go 6, that will make it a complete a full fillet. And then if I go to shell, there we go, and it's supposed to be shelled out 1 millimeter. It will add the other fillet on the bottom. Okay. Now I'm going to show you something really neat here about CAD in general. But we've got, oh, it actually says radius of 5.5 on the other side. So I'm going to go back to there, and it's not a 6 millimeter radius, it's 5.5. So that there's a little flat on the end. Okay. Let's go to fuel tank, right click, and we're going to go to physical material, and this is translucent plastic molding. So if we go plastic, and let's see what we can find. Acrylic clear, epoxy resin, PET. I might just do that. There we go. Let's just do PET. Okay. Now here's something really neat. I'm going to activate all of those. Let's activate the fuel tank assembly. I'm sorry, make those visible and activate the fuel tank assembly. I'm going to bring this down here, bring that down. You can see that I didn't need to do that. I can go revert. So I'm going to bring the fuel tank off to the side. And before I created that fuel tank, let's see, where is it? Fuel tank assembly. I'm going to go back in time. Okay. And now what I'm going to do is go assemble and do as built joint. This to that, everyone. Brass tube to tank top. Okie dokie. It creates a relationship within our sub-assembly. Oh, I haven't named my sketches. Wayne Taylor. Oh, you got me. You got me. Good catch. I have not renamed my sketches. Oh, bad boy. I'm a bad boy. All right. So, Wayne, I have taught you well, or have you learned well from me or somebody else? But yes, we can do that in a moment. Brilliant. Very good. Let's make this professional. Rigid 1, we're going to do brass tube to tank top. All right, do that. And then in the timeline, I'm going to bring this on back. This just is keeping everything organized. Now, I want to put a question out there and you can all find it. But what we're doing is right now, because everything is perfectly aligned, we're getting all these artifacts. You can see it a little bit right now, but if I go on to render, okay, and if I go to in-canvas render, you will see that indeed there might be some really harsh artifacts right here. Does anyone know what that's called? Does anyone know what that's called? Put it in the comments below if you know what that's called. Because basically what we have, the reason why they're starting is these components are perfectly in line with each other. And that doesn't always work in the real world. You can't have two components that are perfect, like two cylinders that mate perfectly with each other. They're always going to be a little bit off. So does anyone know what that's called? Drop it in the comment section below. I'm not going to tell you. I'll just heart it and I'll say this is the correct answer for anyone who gets it. So, but basically the way to get rid of that artifacting is you have to adjust a diameter just a little bit. In this case, I would probably do it on the tank top itself, but that's only when it comes to rendering, and it looks really bad sometimes and you're like, wait a second, that render looks like it's not realistic, and that's because it's creating those artifacts because the two surfaces are perfectly in line with each other. But anyways, now that we've got that, I'm going to go back to assemble. We're going to do as built joint, this to that, everyone. Fuel tank, the tank top, rigid relationships. Let's rename that. Fuel tank to tank top. What are we at? 9990. We've got 10 more subscribers, everyone. Let's just take a little bit of break. All of you probably need a break from me talking as well. 80% on the dark blue theme, everyone. I think it's time to switch to the dark blue. All right. Back to it. Let's hide that. I'm going to go all the way back in time, everyone. Let's go back to the crankcase. Right click, isolate, make it visible, make it active. Okay, expand it. Look at our sketches. Sketch 1. Main body. Okay, sketch 2. This is the inside profile. Okay, sketch 3. Mounting holes. What's the point of renaming sketches? Believe me, when you have a complicated assembly, you want all your sketches renamed so that you can easily adjust things. Remember, the best design in Fusion is one that you can easily edit in the future. If you can't edit and you need to start from scratch, that is also known as the worst design in Fusion. All right, so one way to look at it is will this 6 month from you, how does it go again? 6 months from now, will you basically hate yourself? Okay. So we don't want to hate ourselves, but basically if we 6 months down the line, we look back at our design and we say, what was I thinking? And nothing makes sense. And then you have to start from scratch again. Well, that's the whole point of renaming sketches, right? So I'm just going to call this the top profile. And look at how easy it is. Let's spell it correctly though. And let's go to backplate, right click, isolate, make it active. Okay, same thing, sketches. This is going to be my revolve profile. Okay, we can name it whatever we want, just as long as we know what it is. What a driver profile. Okay, and you might name this something else, but the whole point is what makes sense to you. If you're on a team, you'd have proper naming conventions and everything too, right? Tank top. Got a bunch of sketches over here. So this is main body 1. Main body 2. Okay. I want to call this main body 3. All right, that really doesn't help, but that's fine. And then we're going to do top body. Top body round. We're going to do top small round. And then what is this? Oh, thread. Okay, so now all those sketches are renamed. Brass tube, activate, isolate. This only has one sketch, so we really don't need to, but we can just call it main body. Okay, and then fuel tank, fuel tank. Thank you so much. Who was that again? Wayne. Wayne Taylor, thank you for reminding me. Gotta live by my own standards here. Main body. Perfect. Okay. Excellent, excellent, excellent. We can go back to the top level component, right click and unisolate all. We're at 9993, everyone. 7 more subscribers. Come on, let's do it. Is everyone still sticking with me over here? We've got 25 viewers right now. Hello, everyone. We've got some more. Congratulations. I'm going to send a heart over here. I don't know who that sends a heart to, but I just did. Okay. All right, beautiful. Let's go back to the fuel tank assembly. We're not done. We've got a lock nut. Let's go back there. We're going to isolate the fuel tank assembly. I'm going to create a new component. And let's just call this the lock nut. Okay, create, and we're going to create a sketch. I'm going to isolate this too. Okay, create a sketch. And this is knurled on the outside. That looks pretty cool. Okay, let's just create a sketch right there. This is pretty easy. 6 millimeters on the outside. Right click, repeat center diameter. What is it on the inside? Drill 3 millimeters, and it's a tap on the inside. Okay, so what we need to do is bring back our tank top. And what was this again? If we click on that, you can see in our timeline the 2 profiles that it's referring to, this extrude and this thread. Let's pick the thread, and it's a 3.5. Back to the lock nut. Unisolate. Following great stuff. 9 to 100,000 K. Yes, now I think we're at 7, right? Following, awesome. Welcome, welcome. For all the new ones who have joined, tell us where you're from. 6 more subscribers, everyone. Lock nut, isolate. Okay, let's extrude that profile. We're going to go to 2 sides. Sorry, not 2 sides, symmetric whole length. And the total distance here is what, 2 millimeters? Beautiful. Okay, let's go to create. And I guess what we should have done for this, yeah, what was I thinking here? We're going to do a through hole because this is actually a tapped hole profile. So let's just do that. Tapped hole. We're going to go all the way through. And then this is supposed to be a 3.5 to mate with the other one, right? 3.5.6. Okie dokie. And then we're going to go modify and chamfer. There we go. 1, whoa, that's way too much. So 0.25 is the way to go. And this is brass, I believe. Is it? Brass, yes. So back to the lock nut, right click, physical material, brass. And then look at this. We're going to go close. I'm going to go A for appearance, and we're going to type in brass. And actually what we're going to do is type in knurl. Knurl. Kenya, UK, down under, welcome from Australia. I won't try and do my Aussie accent. That's just not fair. Okay. All right. Brass knurl. Go to faces. Drag and drop right there. This is huge. Right click brass knurled. Go edit. This is off to the side for me, so I have to bring this on over. Let's go edit. Okay, scale. Let's bring this on down. Maybe to 25. Should we go even smaller than that? 20? 10? 10. Let's go 10. Okie dokie. Close. And now if we go to render and go to in canvas render, this will actually put a nice knurled look to it, right? I mean, it's not perfect. It's not perfect. There's ones there that are, they spend a lot of time and try and make it perfect, but oh, what have I done here? Yeah, there we go. Okay, good. Let's go back to design. That's the lock nut. Let's make everything visible here. Isolate the fuel tank assembly, lock nut, single click, bring this on over, and we are going to assemble joint from the center point of that face to the center point of that. And in the drawing, this has moved on over just a little bit. Of course, in real life, we'll assemble it as needed, but that's what we want. Let's go back to relationships, rename this joint, and this is what, lock nut to tank top. Beautiful. Okay. And then the lock nut, again, the sketches, we just have one, so I'm just going to call this main body for this sketch. If you only have one sketch, I generally don't need to rename it, but you can if you want. Now for the render too, we also want to make sure that our threads, if we go to model, that we get no alarms. And there we go. Yeah, that looks great. No alarms. How do I explain this? If you accidentally create a joint when the threads are modeled, then this might create a lot of issues for you with the joints. So make sure to join them together when you're still in cosmetic. You should be 99% of your time spent in cosmetic mode for threads. Now, one other thing that I can see too is you can see this face to the bottom. Let me just go in here and I'm going to measure. So this is the fun thing. I'm going to long click and we're going to grab that face. Just keep on going down till it's highlighted. Okay, so we've picked that. And now look at, I am going to hide the tank top, the brass tube, and I'm going to measure by holding shift and pick that face. So we've got 2 more millimeters that brass tube can go. So if I go back to brass tube, make it active, and then grab this, I can actually go 2 millimeters more down. So let's go to, instead of 2 millimeters, because that will be face to face, that will be coplanar with each other, right? So I'm going to go to 14.5, and now look at this. My pickup tube is going to be closer. It's going to be able to pick up more fuel. Okay, so that looks great. What are we at? 99994, everyone. It's staying still. Please put everyone out of their misery. They don't want to listen to me forever. But if we get up to 100,000 together, this is really exciting. Now, I just got a message here. Only just started Fusion a few months ago and have you and a couple of the tutorials that I follow. I like your delivery of the basics. Thank you, Vigilante351. Much appreciated. Now, let's go to the needle valve. Last but not least in this. Okay, let's go new component. Needle valve. Beautiful. And we are going to isolate it. Back over here. And of course, this is design, everyone, that's based off of a set of drawings, right? So this isn't doing it from scratch. This isn't doing it from our own imagination. This is doing it from a set of drawings, but I encourage you to download the plan book. Everyone do that. Go to the link in the description below, download the plan book, work on all those different engines. Just take it one step at a time. Start with this one, follow the tutorial, go one step at a time, make it work, make it happen. And yeah, I think you're going to love it. So, and it will just keep on improving your skills, right? Okay, so let's go over here for the needle valve. I'm going to do the rotational profile. So again, here I'm just going to create the outermost, let's do a rectangle, the outermost profile. And this is going to be my center line because it's going to revolve to the other side. And we do the extremities, so 5 millimeters from there to there. Okay, and the overall length is the entire overall length here. We have to do some math. 4.1 plus 7 plus 1 plus 1.5. Oh boy, don't quit on me now here. I can't measure that. What? I can't calculate that. So what is this in real life? That's 5.1, 12.1, 12.1, 13.6, right? Let's just type in 13.6. Well, how come it's not going? Well, now it's working. Let's just verify this. I'm going to do the same thing. 4.1 plus 7 plus 1.5 plus 1. All right, that worked. Okay. And now we're just going to define all of the other geometry. So how does it look in real life? We're going to go down like this, down like that, bada bing. Okay, something like that. Great, and we're just going to define this one step at a time. It actually would not be a sharp point at the end, so I'm going to delete that, and I'm just going to pop this down right there. Okay. Now, let's just define this one step at a time. D for dimension. Our second diameter here is 3 millimeters. Our next step is what? This is an 8BA, and I've already forgotten what an 8BA is. Is that 1.6 millimeters? Oh, an M2. Okay. So we're just going to call that 2 millimeters right there. This next one is going to be 1 millimeter here. Perfect. And then I'll do a very end over here, and this is just going to be really tiny. I'm going to go, what, 0.1. I mean, that's going to be nice and still sharp in real life. But, and do we have an angle for this point? No, we do not. But we do have, from this shoulder to the bottom, 4.1. This next is going to be 7. This next is going to be, what was it, 1 millimeter, and everything should be, oh, it's still not fully defined. Oh, this angle right here. So I am assuming that this is going to be, let's go 5. Oh, it can't be 5. Okay, let's go 10. Does it look like 10 in real life? Well, it looks like probably 12.5. Oh, sorry. 7.5. Yeah, it looks like 7.5. Okay, I'm just assuming it is because it's not defined on the drawing. Beautiful. Let's go finish sketch. We can go revolve. There we go. Excellent. We're still in needle valve. Again, the sketch, we don't need to rename this necessarily, but I'm going to call it main body. 9996, everyone. Okay, and this is supposed to be brass as well, so we're going to go into the needle valve, right-click physical material, drag and drop the soft brass. Beautiful. And then we're going to go A for appearance. Back to the knurl, everyone. Make sure to click face. Boom. Just like so. And then we also have to put a thread on this profile right there, and it's 2 millimeters. So let's go back to the tank top over here. I'm just going to move that off to the side, and this activate tank top. If we click on that thread, that's our hole, the hole here, 1.6. 1.6. So if I go back to the needle valve and change that thread to 1.6, what will it look like? Oh, it starts. Yeah, it should be fine. I mean, that's a really small thread, right? No worries. Assemble. And here we can either leave the needle valve activated or activate the fuel tank assembly. It doesn't really matter because the joint is, Fusion understands when you create a relationship or a joint between two components under one subassembly, it's going to put that relationship right there. Okay, so let's go to this face to the center point. And then back here to the center point. Okay, obviously that's way too much. So I'm going to pull that on back. And now what we can do is, this is just for cosmetic. You know, in real life, this is going to be twisted down. Oh, and we actually have to add a spring. You know what? I think I might let all of you do that on your own, add a little spring to it. But basically, the spring is going to keep it under tension, and it's going to prevent it from, you know, backing out or being pushed in. It's going to keep it positioned. But basically, this is going to be adjusted, and it's going to match up or mate up with the brass tube. And the brass tube is, what is that called now? When it starts, when it's under power, when the engine is under power, it's actually going to draw fuel through that. And if the needle valve here lets in a little bit of fuel, then obviously that's going to allow a little bit of fuel to go in the engine. And a little bit of air is going to be coming through this right here. But anyways, that's our fuel tank assembly. 9998, everyone. 9998. We're almost there. And in the meantime, I'm just going to save. Oh, this is getting exciting. Okay, but anyways, that whole page, sheet 1 is done. Sheet 1 is done. And the rest is going to be pretty easy. Hopefully we can get this done fairly quickly, because sheet 3 is just our cutout view, right? So let's just, I'm just going to have another couple sips here. Before we get to 100,000 again. Oh, one question I'm asked: should we render the images in orthographic or perspective? Great question. So orthographic mode helps you design a whole lot better. But orthographic mode is not what the eye sees normally. There's no perspective. The eye always sees in perspective no matter what. So yes, I would suggest, and some love designing in perspective. Some absolutely love it. I really don't, because perspective, well, let me show you. If you go to the front view, all of these look like circles, right? That's what they are. They're circles. But if we all of a sudden go to camera and then go to perspective mode, you can't actually go spot on here. As soon as you do, it's basing it off of the origin, right? But now you can see, instead of looking at it directly on the side, you start seeing perspective on everything, which is really hard to model in. So anyways, design it in orthographic, render it with perspective. And this is the cool thing with perspective. If you go to your scene setup, scene settings, you can actually change your focal length. So it's perspective, but just like a camera, right? If you use a macro lens with a camera and you look right into something, this is where macro is like really close, right? So you can zoom right on in here and do some really cool renders. You know, maybe this isn't the best because I haven't added any detail to the rest of all this, right? But you can do perspective like that, or in real life, the zoom, the farther you zoom out, or the greater the, oh, we're at 9999, everyone. The greater you focus your focal length is, then you've got a zoom lens, and that's great for different types of portrait photography and things like this. It's a whole thing you get into. But anyways, yeah, let's go close. So you want to definitely do your renders in perspective, or else it does not look right. So orthographic, if you zoom on in here, oh, it just has exposure level at this point. That's no good. Yeah, you can't even change the focal length. Focal length and depth of field. Oh, we're so close. So your depth of field, if I click right there, then it's going to add a really nice blur. Of course, this blur is way too much. So let's go on down to 0.116. And like real life with macro, as you zoom in on something, everything else becomes blurry around it. So that's basically what we're doing right now, and that's all because of perspective. You can't get those views anywhere else, any way else other than perspective. So let's close that. Let's stop the in-canvas render. Go back to design. Everyone, we're at 9999 right now. This is exciting. Thank you, everyone. This is so great. I'm excited here. Smash that little heart button or whatever it is. I've got a bunch of congratulation things coming up if you can. It's just fun. It's just fun for me. I'm going to do one of each. I'll do a heart here. I'll do the little bouquet 100. Oh, there we go. Come on, 100,000. Is this really happening? This is great. 100,000, everyone. What do you think? Well, I don't want to just wait here forever. Okay. Let's go back, live stream. Okay, so let's move on to sheet number 2. Fuel tank assembly is done. Oh, let's just rename. Let's just rename this last joint here, and this is going to be our, what was it again? Our needle valve to tank top. Can hear the sigh. I love it. Oh, there we go. There we go. There we go. Hey. 100,000, everyone. Well, oh, I love all of the joy coming in. Thank you all. Thank you all. This is fun. What a treat. What a treat. Is this actually showing up for you? 100K? It takes a moment. It takes a moment to get through. So now we're, yeah, there we go. Okay. Congrats. Congratulations to all of you too. You have many of you have been with me from the get-go. So yeah, amazing. Amazing. Thank you so much. Okay, I don't want to dwell on this for too long because it's probably going to jump down. Actually, I have no idea. Watch it jump down to like, I don't know. But anyways, let's get back to it. Let's we've enjoyed that process a little bit together. Let's finish this up together. I don't want to spend the rest of your day. Oh, thank you everyone. Thank you for your support. It may have been my other channel, Rambling Geek, as the 100K sub. Yay! Thank you, Wayne, thank you for joining and subbing. Awesome. Thank you, everyone. Your comments are really encouraging. Thank you. That's all I can say. Let's keep on moving on here, everyone. Let's we can enjoy this a little. Oh, we're back. 100,001 now. Okay, this is exciting. All right, let's keep on going. Add new component. The next sheet 2. What should we do? I'm going to do the cylinder. Why not? Okay, let's hide that fuel tank assembly. Let's isolate the cylinder. Create a sketch on the XY. Oh, now we're in perspective mode all of a sudden? No, we're in orthographic. No, we should be in orthographic. It looked like it was in perspective for some reason. Anyways. Okay, let's do this. Our cylinder is 8.5. Well, thank you again, everyone. I keep on getting more nice comments from all of you. Thank you so much. Thank you. Awesome. What a privilege. This is great. Okay, let's keep on going. 6.5 for the inside. Let's go finish sketch there. We're going to extrude that. Oh, there we go. Yeah, so it was in perspective. Let's go up to 19.5. Yes, thank you so much. I'm glad that you feel connected to this channel. That's great. What does isolate do? So basically, right now we have a ton of different components, right? So I'm just going to activate all of them or make all of them visible. Let's say that we only wanted to work on the lock nut. Well, what you'd have to do is go and you'd have to hide all the other components, right? But isolate, right-click isolate, hides everything else. It just shows that one component, but it doesn't activate it. So make sure you activate it. So here, again, I don't want to go through and, make everything visible if I want to work on the cylinder. So here I'm just going to activate the cylinder, right-click isolate, and then everything else is hidden. So nothing else. I won't create any unnecessary assembly relationships. That's what the isolate button does. Very good. Now, let's see here. We've actually got, with the cylinder, we have two components. If you look closely, we've got this where it connects to the fuel tank assembly, the fuel tank top. There's a little piece there that needs to be soldered into place. So yeah, thanks, Wayne. Yeah, glad you got that. Okay, cool. So let's just take this one step at a time. I am going to create a sketch on the YZ. Let's again do this here. I can P for project the entire body. Yep, let's hide the body, zoom on in, and I'm just going to create this little exhaust section here. So 2 millimeters high by, and actually this spans the entire distance. Sorry, repeat. There we go. 2. Perfect. And we're going to make this horizontal. And actually, should I do this? Yeah, we should do this way. Okay, make this vertically constrained right there. And 6 millimeters to the bottom. And then here, I actually want to make these collinear on the outside. So who do we, sorry, I'm just looking at a comment here. Someone should gift me a 3D printer to practice. Congratulations on your 100K. We've all been together from the beginning. Excellent, excellent. Well, if you're gifted a 3D printer, that would be really cool. I wish I was gifted a 3D printer. That would be awesome. Okay. All right, there we go. So we've got that extrude. Let's grab this, and this actually goes to 2 sides. We can pull this one out here. And let's look at our profile. This goes to 1.5 millimeters. So we have to do a little bit of a, that's 4.25. Awesome. Let's go expand this here. We want to go to minus 4.25 plus 1.5. And then the rest here can just go to 4.25. We'll cut that all out. Okay, there we go. And now we're going to mirror this to the other side. Features, grab that extrude that we just did, mirror plane. Beautiful, identical. Excellent. So that's for our exhaust. On the bottom, let's go to create sketch right there. And our circle is going to be somewhere here. Let's do vertical constraint. And this position, this is interesting. Our dimension is D for dimension. We're going to grab arc tangent from there to there. So how I did that, I'm going to show everyone again. D for dimension, right click, arc tangent, grabs it from the arc tangent to the arc tangent, which is what's specified on our drawing. So 0.5. Congrats everyone. Thank you so much. Can you show how you alter screw joints to behave as a screw rather than rigid to check for interferences? Okay. Let's see. As a screw needle valve rather than rigid to check for interferences. Yes, let me just think of how to do that. I'm just thinking with the needle valve itself, that might not be the best way to show it. But if I have time at the end, please remind me, because that might be a whole nother tutorial that I can show. That would be really cool. Anyways, thank you for that. Thank you for that request. So 3 millimeters is the diameter. Perfect. And then we can extrude this. We can just extrude both profiles is fine. And how deep is this? Minus 7.1. Excellent. And then what we can do is we can fill it. That's not really, oh, it is accurate. That goes to the end. Yeah, that's fine. So we can just go minus or 1 for the fillet right there. This is just saying to use a round nose end mill. So we could probably use, if this is 3 millimeters, so we can go 1.5. Okay. And again, yeah, that's probably fine. It's just a little bit of relief there. So okay, very good. Anything else we need to do? We need to also chamfer the inside right there. And this is going to be to a sharp edge. So we need to do a little math here. It's 1 millimeter spot on. Does a sharp edge right there. Cool. Now let's go to construct tangent plane right there. And now we can build a sketch, right click and create sketch right off of that. Create point, vertical constraint right there. D for dimension, this is 5.5 millimeters. Right to there, excellent. Finish sketch. And now we can do a hole through it. Again, simple, simple. And what do we want here? What size is the hole? Drill number 55. So number 55 drill size. Ask Mr. Google, 1.32 millimeters. Oh, sorry, let's go 1.32. Excellent. And how far do we go? Here I'm going to go 2 and pick that inner face. Great. So in reality, that looks way too big. Gauge drill has, or 1.32 millimeters. Interesting. So basically what we have here are 2 components. That's true. But we're going to have 2 bodies because these are going to be soldered together. So we could either define them as 2 different components or 2 different bodies. It doesn't really matter in this instance, but I'm going to keep them as 2 bodies. So yeah, I think that's the way to do it. I think that's the way to do it. So let's go back to that one sketch that we just created. And actually it's the construction plane, right? Yeah, we can go back to the sketch though. And edit that, and let's create the other profiles for the mating component here. So let's see. 5 millimeters. Brilliant. Excellent. Okay, and then let's extrude this. Interesting. So this is not being counted as a closed profile for some reason. Very interesting. I think we've got a little problem with Fusion right now, but I might have to reboot Fusion because that should be defining it as a closed profile. But maybe what I'll do is I'm just going to exit out of that. Let's just delete it. Let's just delete it. There we go. Okay, I'm going to create another one off of that plane. Right click and sketch. Okie dokie. And now we're going to do the same thing here. Now this doesn't find this profile, the center of it, because this circle, even though it's cut out, it is a complex surface now. So it's not going to find the center, so we're just going to have to redefine it. Again, make it vertically constrained, D for dimension. Call this 5 millimeters, just like so. And now we have a closed profile. So it was just a little workaround. Let's extrude there. We're going to go to 2 sides. V8 engine, I just see a question. The V8 engine is still in process, so hang tight. I've got a lot of work on it still. I've been doing a lot of the drawings, and we're right at the a critical part where we're trying to just finish the drawing so that I can produce the tutorials. The drawings are the hardest part because I've got to make it in such a way that everyone can understand and then make it available for everyone to download. But the tutorials are the easiest part. So the camshafts is what I'm working on right now and timing that to the engine itself. So thank you for holding tight with that. I haven't been deliberate with putting it off. It's just life recently has been really busy and I haven't been able to get to it. So thank you for waiting for that. That would be great. Just keep on waiting. Okay, so let's bring this on down. I am going to make sure that it's buried but doesn't go through the other surface. And that's in the one direction. And in the other direction is going to be the entire extremities here of 4 millimeters. And here I'm going to create a new body. There we go. So in our bodies, we have our main cylinder, and then we have our additional body. So I'm going to rename that right now. cylinder, and then this is the threaded body to be soldered. Okay, great. And now what I can do is do the combine using the combine tool. Target body is going to be this, tool body is going to be the cylinder, and I'm going to cut. Okay, cut it, and I want to keep the tool. There we go. Let's hide the cylinder, and now I've got this body, which I actually want to delete that right there. And now I've got this beautiful body to work with. Excellent. And now I can create a hole right there, and this is going to be tapped all the way through, and I believe it was what, 3.5, right? 3.5 all the way through. No worries. Thank you so much for your understanding there, Dylan. Looks like Dylan. Awesome. Okay, beautiful. So now we've got these two bodies, and here we don't need to join these together. In fact, we cannot join those two bodies together. They're two bodies within one component, and again, this is going to be soldered, and in reality it's going to be one component. Here's an easy way to remember everything, everyone, is components move, bodies do not. So these two bodies, once they're soldered together, there's no way that we can move them at all, right? So I see a little discrepancy here. That drill number 55, maybe drill number 55, drill bit size. I really don't think it's that size that we had in there earlier. Number 55 is 0.052 inches. Yeah, that looks like it's way too big, but that's fine. All right. Cool. There we go. And what can we do now? I think the cylinder is all done. Okay, so we could, we've got an unconstrained sketch. So what's happening? That's why. Okay, let's go D for dimension. This is 5.5 from the local origin. Excellent. And now that looks a lot better. Okay. Amazing, amazing, amazing. I think that's it for the cylinder. And again, we can rename our sketches. Let's just do that right now. Main body. This is our vents, or our exhaust, I should say. Exhaust ports. This is our bottom relief. This is our side hole. And then last but not least, we're going to have our side feature, our side body. Okay, there we go. We can minimize everything there. Great. Now what we can do is make our fuel tank visible and our crankcase visible. Let's make our top level component visible there. Actually, let's hide the fuel tank so far. I'm going to move the cylinder on up there, right click joint, and we're going to grab the center of that, and we're going to fix it to the center of that right there. Beautiful. Now our cylinder, what is it? It's leaded steel. So let's just keep it as steel. Here's another little secret. I can click on the joint, right click, and go find in browser, and it will find that joint for us right there. So I'm going to go cylinder to crankcase. Awesome. Let's do that. Now let's make the fuel tank assembly visible. I'm going to pull that on out over there and do the same thing. Joints. And this is actually going to join right here. So I'm going to grab that face to that face. Okay. Boom. It's going to nestle everything together. And again, in real life, this is going to be, I guess that's all going to be like in perspective of how that's going to actually assemble. But basically, you're going to flip this around, screw that in, and then this distance we really don't worry about. And then the threaded nut, we're just going to tighten that so that nothing else loosens, right? But again, I'm going to right-click that joint, find in browser. Okay, and this is going to be the fuel tank, or the tank top, I should say. Tank top to cylinder. Beautiful. Looking great, everyone. Make sure you save often. How's everyone doing out there? Are you sticking with us? Anyone who else is new, make sure to tell us where you're from. Make sure to comment, because I'm going to just take you on one more little tour over here of our Patreon page. Let's just do that. Okay, Patreon, we've got a free gold membership that I'm going to give to any one of you who has commented. I'm going to pick you randomly who has joined this live session, so make sure you comment. How much is a gold membership worth? Well, this is for an entire year, and so $25 a month for an entire year. It adds up, and this is pretty well the best. You've also got ultimate membership. Again, titanium and gold are, in my opinion, the best. What's the most worthwhile. Aluminum is great too for those that want to support the channel, because you've been learning from us and just consider it beneficial. We'd really appreciate it. We have a lot of aluminum members, which I'm really thankful for. It helps us, keeps us going. But titanium and above is where you get access to every single tutorial and resource on our site. So check it out. But those that comment, you're going to be randomly drawn for a year membership. So please don't forget to comment. Now we've finished that. That's great. What should we do next? In real life, we would probably do the crankshaft. So I'm going to do that. Right click, new component. Crankshaft. Right click, and we're going to go to isolate. Awesome. And again, the datum reference, where's everything coming off of? Well, I'm going to base it off of the XZ plane here. And you can see on the drawing, we've got a bunch of dimensions going to the left of one surface and then going to the right of another surface, of the same surface. So that's the datum reference. That's what everything is measured off of. So that's what we want. And that particular dimension is 6 millimeters. Perfect. We're going to start off with that. And then what we can do is do another one on the this is the next dimension, which is 4 millimeters. Okay, I'm just going to start with that right now. Let's extrude that. And this is going to be what? Minus 8.5, 18.5. Beautiful. Okay, let's go back to that first sketch. And now I'm going to extrude those two closed profiles. And this is going to move over 0.3 millimeters. Okay, I'm going to hide this. I'm going to rename this to the shaft sketch. Okay, create sketch on the back here. And we're just going to keep building off of this. So this is going to go all the way up to the 11.3. Perfect. We'll extrude, grab those two profiles. And what do we want here is 2.3. Excellent. Now, if you look closely at the drawing, we actually have a drill and ream for press fit of 2 millimeter dowel pin. So I'm just going to create this as one body because in reality, this could be machined all as one. The Z fighting. No, I think that's the first. Aussie Daz 60. Hi from Australia. Well, hello. Did someone mention the Z fighting? Yes, that's what it's called. So it's got a few different names, but yeah. Thank you. You got it right. Thank you for mentioning that. So remember when we are in our render environment, I'm just going to turn everything on. Let's go to render. Come on, let's go to render. And then we've got two components that are perfectly fitting together. And then we do our in-canvas render. Oh, of course, I've got depth of field on right now. But basically, if we were to let this render out, those two surfaces those two surfaces, the ID and the flat surface there, are going to be fighting, and they're going to have these. It's just not going to look the best. So that's what he's talking about. Good job. Thanks for mentioning it. Okay, and the way to fix that is that we just adjust one body a little bit. So I'd probably adjust the tank top, make that one surface a little bit smaller, and I think it would look great. So anyways, let's go back to the crankshaft, unisolate, and then isolate again. Perfect. So again, we could have made this as an assembly, crankshaft assembly, and used a dowel pin, created a hole and then put the dowel in there for the crankshaft. But I'm just going to create it as one body just for fun. You know how to do that now, which is great. But let's go to Sketch first. Create, and we're going to do a circle. Okay, let's make this vertically constrained first of all. D for dimension. And this is supposed to be what? 2 millimeters. Excellent. From the center point to center point, we want 3.75. Perfect. Finish sketch. Extrude. So I hope you can see, like for me, yes, there are a lot of shortcuts, but I have my hand on the 3D connection. I've got the compact version. I've got my hand on that a lot, so it's a lot easier for me. And another reason is the keyboard is right behind my microphone, so I can't see the keyboard. And for me to look around every time, and you can just see my voice changing, I'm looking around, it's easier for me to just click on extrude. Whereas in reality, I would probably use the shortcut keys a lot more. But I hope you understand that sometimes in real life, it's easier to click on the toolbar than it is to remember the shortcut and to click on the shortcut. So, anyways, you don't have to worry about that too much. Let's go to chamfer right here. And instead of equal distance, I'm going to go distance and angle because it's a 5 degree. So we're going to go down. This is actually going to be 80 degrees. 85 degrees. Whoa, not 805. There we go. 85 degrees. Okay. Yes, and it's going to be 3.5. I should actually flip. Yeah, that's what we want. And now we can go 5 degrees there. Okay, we're going to flip and then grab this dimension, and that is supposed to be 3.5. Excellent. And then we do another hole right off of that face. And we're going to go to a distance of 10.4 millimeters deep, and our thread is a 6BE. So we're going to go back to asking Mr. Google of what a 6BE equivalent is in metric. So that's an M2. So let's go over here to M2, and that looks really small, doesn't it? Yeah, that looks too small for my liking. So I'm going to go 2.5. That looks a little bit better. Okay. Perfect. Oh, see, the subscribers has gone back down to 100,001. Oh no, back to 100,000. We've celebrated too early. It's Oh, hang in there, everyone. Hang in there. Hopefully it won't go too low. Stay with 100,000, please. Okay, there we go. So we've got our crankshaft. And I think all of our dimensions, have we checked them all off? Yes, yes we have. Okay, beautiful. Great. Now let's look here, because we've got this fillet right here, and this is not defined on the drawing, but I'm going to assume that this is going to be a 0.5. That's probably way too big. 0.25. Let's just call it 0.25 for now. And we are going to turn on the crankcase, make our top level active. I'm just going to bring this off to the side, and we're going to go to Assemble, Joint, and it's the center of this face. So click the face first, then the center, and we're going to click the corresponding face and center right there. Now, let's go just OK for now. I'm going to go to Inspect, Section Analysis, and pick our X or a YZ plane. Beautiful. Okay, so let's look here. This is what this is referring to. The chamfer needs to be bigger than the fillet. So the chamfer right now is really big. So if I just click on that chamfer, you can see in the timeline, I can see it right now is highlighted. But if I go right click, I can go to Find in Browser. Sometimes it says Find in Timeline, but since this is already lighting up, it's right there. So I'm going to call this 0.35. And let's look a little bit more here. So it's still a little bit bigger than this fillet, which is fine. As long as the fillet is no bigger than this, and this is where we put tolerances on everything, right? So I think that's okay. Maybe, I mean, I'm just worried about this profile right there. You can also see that I created this counterboard. It's not big enough. So it actually needs to be at least a little bit bigger than this diameter. So again, I clicked on that diameter. I can see it's 11.3. So I'm going to assume that this diameter is going to be 11.5. So I'm going to go all the way back in time. And again, as I clicked on that, you can see in my timeline, I don't have to activate the crankcase. I can just see it in the timeline with the angled dash marks above it. That's the revolve. So right before that is the sketch. Okay, beautiful. So 11 was the dimension that I picked. I'm going to go to 11.3. The reason is I don't. I'm going to put this. I'm going to put this to 12 because that's what we ended up going with, and I'm going to call this 11.5. There we go. Let's go finish sketch. Goes all the way back. So now you can see this counter balance over here is slightly less than that counterbore. So there's not going to be any interference right there. So there we go. Oh, we're down. We're below 100,000 now. Well, this is really disappointing. Somebody doesn't like us out there. Okay. 99,000. Anyways, not the biggest, not the end of the world. Hopefully it will go back up. We celebrated too early. Oh no. Okay, so here we don't want this as a rigid joint. So I'm going to right click that joint and go edit. And here we want to go to motion and we're going to turn that into revolute. We can hide the analysis, the section analysis so that this is full. There we go, preview motion. Excellent. So that's working. You can see everything is working together there. Beautiful. Okie dokie. Awesome. Okay, we can click on that joint, right click and go to find in browser. All right, here it is. So we're going to go to crank shaft to crank case. Perfect. Awesome. So now I can single click it and I can move it. As I move it, you can see the position, this little position menu comes up here and I can revert so that it's perfectly 90 degrees off of the XY plane. So if I right click that and go edit, I could also go to motion and put on a rest. So this is 0 degrees right here. I can go OK. So now if I move this by hand, I release it and it snaps back to its rest position. So then that dialog won't come up where it's asking me to revert position. So that's just saying I always want it to go back to that rest position, which I can do either one. Hey, we're back up to 100,000. Okay. All right, let's keep on going, everyone. Conrad next. Conrad, let's do it. Okay, so that was the crankshaft. Again, I can rename this large diameter and then pin. I can just call this the pin. Okay, there we go. That sketch has now been renamed. Great. Okay, let's hide that crankshaft. We can hide the crankcase as well. Let's go to create another component. This is going to be our con rod, and this is 2 words. There we go, con rod. Create. Let's go back to the home view, create sketch, and here, which way are we going to create this? I'm going to base it off of where the holes are going to mate. So let's do it on the XZ. Okay, and the con rod here is kind of funny. Alan subscribed with my other account. Oh, thank you. So you brought it up to 100. Oh, thank you, everyone. That's great. I hope it will keep on going up. Maybe it will get to 100,000 with this stream, and then after this, it will go down to 50,000 or something. I have no idea, but this has been fun nonetheless. Do you know what? If I was only shooting for 100,000, I'd rather be very happy or very disappointed if it didn't stay or go above, right? But I'm not doing it for the number of subscribers. I just love doing this, and being with all of you has been an absolute blast. So anyways, thank you again for all your support. Let's keep on going on. So we're at the con rod. And I think what I'm going to do is, this is actually manufactured in a funny way. It's using, it looks like some sort of drill rod or something. Oh no, it's aluminum. So it's like, you know, just a regular piece of cylinder, of round stock. But I'm not going to design it that way. There we go. Let's go on over back here, and I'm just going to design it like we're going to make it out of flat stock. So oh no, this is 4 millimeters. Okay. Let's do another one up here. I'm going to make this vertically constrained. D for dimension. Grab that. This is also going to be 4 millimeters. The distance between the two, D for dimension, obviously. Let's go on this side. 14 millimeters. I really hope you don't hear me coughing. I'm trying to mute myself so you don't hear me coughing, but okay, so 14 millimeters there. And then we can create a line from top to bottom. I'm going to create a center line that I can reference my symmetry on. Another line off to the side. I'm going to turn this middle one into a construction line, make these symmetric to the center line. D for dimension. There we go. Grab that there, 3 millimeters. Perfect. Let's finish that sketch. And like I said, I'm just going to pretend that this is all flat stock here. So let's extrude that. We're going to go to symmetric whole length, and this is going to be a total of 2.3. Very good, very good. And then we're going to create a hole there. And do you know what I should do? I'd like to use, yeah, I'm going to create a sketch right there, and then I can do a point. Are these two different hole sizes? Yes, they are. So what am I doing? No need to create a sketch, just create a hole. I'm going to do this one first. Simple hole, doesn't matter. The drill size is actually going to be 2 millimeter ream. So we'll go all, right click, repeat. Let's do the same thing over here. This is going to be 1.5, I think it is, 1.5, yeah. Oh, then it says file for clearance on the top, so that's pretty cool. Subscribe to my third account. Alan, awesome, awesome. Thank you all. That is great. That is great. We're at 100,002 now. So beautiful. That's awesome. Thank you. Okay. All perfect. Now my fusion is starting to slow down. Okay, so we've got our con rod over here. Again, the actual manufacturing of this is a little funny, and it does say file for clearance on the very top. No worries. I think this is sufficient. It does have a little, I think I see why. It doesn't want it being rubbed on this face, but I don't think that's going to matter too much, to tell you the truth. So let's go back to the crankshaft, activate the top level component, make the crankshaft visible, and then we're going to bring this off to the side, and we are going to go to assemble joint. Now, you might think that creating a joint from a revolve joint is the way to do it, but actually I want to create a joint based off of that face to that face, and this is going to be not revolute. So even though this is going to be basically the motion, you know, as this crankshaft rotates, this will also rotate, but this is not the joint that we want. We actually, in real life, there's nothing that forces the con rod to be directly against this face. In real life, this is actually going to be moving back, you know, at an incredibly instantaneous speed, and it will be perfectly centered with the cylinder. So we don't want to use revolute, we want to use cylindrical. And that, if we hover over cylindrical, it rotates and slides a component on a single axis. So that's our single axis. It will rotate and it will also slide back and forth. Now, we could put a little bit of motion limits. So I can click on slide over here and click on minimum and maximum. So it's not going to be able to go to the left at all. And then the maximum is, I'm just going to put a little bit of a, like a 1 millimeter, right? So in real life, I'm going to be able to move this, and I'm going to be able to rotate her along like that. So as our crankshaft spins, of course, this is going to reset to 0, right? But I will be able to move all of this together, and that's kind of that's what we're looking for. So anyways, let's click on that joint, right click, and we're going to go to find in browser. Okay, Conrod to crank shaft. Excellent. Great. Now, what do we need to do? We need to create the piston, and the piston has a little wrist pin, and the wrist pin is not defined anywhere. It just calls it a 1.5 millimeter wrist pin. Okay, so that's fine. Let's do that. We're going to call it the piston assembly, because the piston, again, is made up of both the piston and the wrist pin. So let's, before we continue on here, let's go back. Cylinder is steel. Crankshaft is also steel. The conrod is aluminum, is T3. So let's go to physical material, and we're going to go to T3. T3 aluminum high strength alloy. Boom, drop it. Great. Let's save it. There we go. All right, 100,003. Who else saw Ty Sir struggling at this point in the video? Australian mate Diesel. Oh yeah. You know what? I am as much as I'm a teacher, I'm still a student, and I always want to be a student. So I keep learning stuff. But I'm glad you remember that. That's awesome. Okay, let's go to our piston assembly. Piston assembly. Under the piston assembly, I'm going to create a new component and call this our piston. Great. Let's go to the piston, and I'm going to isolate it. Go back to ISO view so I know which planes I'm looking at, construction planes I'm looking at here. Piston. So it's actually, the hole is going to be in line with the y-axis, right? So I'm going to click that, and here I am going to create, in this instance, I'm going to create a rectangle like this, and I'm going to say midpoint to the midpoint of the line. All right, let's just do that. Let's have fun. And then I can create a center line going from there to there. That's fine. I guess that was totally unnecessary, but that's whatever. That's all part of it. Okay, so we've got 2.5. So I'm going to go something like this to there, and this actually is positioned about that location. Okay, so grab those two. This dimension is 5.3, and our outer dimension is 6.5. Great, and our overall height, 7 millimeters. Excellent. Is everything fully constrained? Yes, yes it is. Okay, let's revolve this. Perfect. Great. Now I can create another sketch down here, and I'm going to put this keyway, this slot. Center point slot. Again, hover your mouse center, move it on over, and then move it on up. Okay, and then we can start defining this too. So D for dimension, and what we want is these two surfaces to be tangent to each other. So we've got the, not surfaces, but well, I guess they are surfaces after they're extruded, but this to that. Great. And then the overall width of the slot here is going to be 2.5, and that should lock everything in. Yes, it does. Excellent. Grab that. And do we have a height here? No. No, we do not. So what I want to do is I want to bring this on up. Actually, I want to go to an object, go to the top, and then go to offset. And I'm going to do offset -1 millimeter. There we go. That's approximately in the right location. Create a sketch. XZ in this instance, I can slice it down the middle, and I want to put the hole for the wrist pin. There we go. And this is 4 millimeters from the local origin. And this is, what was that size again? 1.5 millimeters for the wrist pin. Let's go finish. Okay, extrude. We're going to go to symmetric and then go distance all, and it's going to cut that out. Beautiful. So that's the piston, and then we also need the wrist pin as well. So here we go. I actually want to keep that last sketch that I just created, and again, I can just rename these. I can call that the body keyway. It's not the keyway, the slot, I should say, sorry. Sketch is going to be pin. Okay, I want to keep that active, but here I want to go back to the piston assembly, and this is really neat now. I'm going to go to activate the piston assembly and go extrude, and here it's already selected that closed profile. So let's go to symmetric, whole length. Let's bring this on out. We don't want to go all the way through, but something like 6 millimeters is fine. And here we go, new component. Because we've activated this as our active component, it's going to create a new component under this umbrella. So it's not going to create it under piston, even though the sketch we're selected is under piston. That's just the reference sketch. So if I go OK, you can see now this is a subassembly, and piston and wrist pin are separate. Wrist pin. The benefit of doing that is that we don't have to fight with, oh, and then I can hide the sketch too. We don't have to fight with sketching right now, or joints. I can go joint, and actually we can go as built joint. As built joint, perfect. This and that. Rigid, we actually want, in reality this would be rigid. Let's go OK. Perfect. Find this in browser. There we go. And we can go wrist pin to piston. Okay. Awesome. Anyone else is here? Yes, we've got CAD with Het Patel. Excellent. Hello everyone. Please, everyone, if you haven't done so already, let me know where you're from. Everyone who comments will be automatically drawn or automatically put into a draw to win a free gold membership, an annual gold membership for our Patreon channel. So anyways, we'd love to see you there. So here we go. This is looking great. Now, what do we have here? The piston is cast iron. So we're going to go to the piston, go to physical material, and we're going to go to cast iron. There we go. Drag and drop. And now you can see that the cast iron, if we go edit, no, that's the density. So we don't want that. Cast iron right there is way too grainy. So A for appearance, and then go to cast iron. And here we can scale it down. Yeah, and this just makes the grain a lot more reasonable. We can go all the way down to 10. It really doesn't matter. There we go, close. So now if we zoom on in, you can see that the grain structure is really tight, which makes a lot more sense. Okay, good. So now here comes the fun part with assembling. So we've got to turn on the conrod, the crankshaft, the crankcase. Actually, crankcase we don't need. We need the cylinder. Make everything top level component active. And here we go. We could actually hide the cylinder for now. And our piston assembly, we're going to go assemble, joint, and the middle of this. So remember, hover over your wrist pin and select the triangle. And then we're going to do the center of this as well. So we can hover over that hole, click anywhere on the cylinder, and then it will allow us to select that midpoint. Perfect. Motion. This is going to be revolute. All right, there we go. Let's hover over that joint, right click, find in browser. Perfect. We're going to go wrist pin to conrod. Okay, here's the fun part. Let's hide that. Let's turn on the cylinder. And now we want it to follow in line with the cylinder. So what I'm going to do is I'm going to assemble joint. And this is what I like to do, is I like to grab the top of that cylinder, or top of that piston assembly, or the piston, and I want to joint it right there, even though it won't let me right now. So I want to flip the motion to slider. It's going to go up and down. Obviously, it's going the wrong way. I want to flip it. And here's where I add some motion limits. So obviously, I don't want it to go any higher, but I do want it to go lower. And I want to bring this all the way down to something like that, to -13, and go OK. Now let's see if this works. Yes, yes it does. I'm fighting with it a little bit. Oh no, it needs to go down even further. Okay, so let's click on that joint, right click and go to edit joints. And now for the motion, I'm going to go a little bit further because it's maxing out. -15. Okay, there we go. So now we can see interference here, right? If I bring this, you can see it's actually hitting the side wall of that. So we could fix that, no problem. I could adjust this so that it's just what the drawing says. Make this a little bit more. They'd probably put that on a lathe and turn this down actually. Okay, but you get the point. Now I'm getting really hoarse, everyone. Sorry about that. But you can see, actually, how can we see this a little bit better even? Let's go to Assemble, and we're going to create a motion study. And this is the whole point about labeling the joints as well. Select joints to animate down here. I'm going to pick the crankshaft to crankcase. And here we have time to degrees of rotation. So it starts at 0 and goes up to 100. Right now we're at 0 degrees. If I click on the very end, again, left to right is time. So if I select 100, this is 100 frames. The angle I'm going to get it rotating, it's this joint over here, so it's going to rotate 360 degrees. Okay, let's go enter. Let's go to loop and then bring the speed all the way down and let's see what happens. There we go. Okay, let's go OK, set this motion limit, this motion study there. And now what I'm going to do is we're going to inspect section analysis, and we're going to move this to midway, something like that, so we can see the insides. Now, when we go back to our motion study, which is in the browser, right click, edit. Okay, again, bring speed all the way down, loop, constant loop. Now, is it actually hitting? Yeah, it is. It is. You can see it's hitting. It's hitting on the side there. So that obviously needs to be relieved, and that's probably why they turned it on a lathe, right? And then up here as well, you can see that this is, oh, that's making me sick. Let's just pause it. So this is where they, on the drawing, it says file this down, right? We could actually make the piston a little bit deeper, or we could put that on the drawing as well to file that out. But you can see all of the interference right here. Now, that's looking really good. At this point, this is where we want to go and start fixing all of those different interference, you know, parts of our con rod and everything. But I hope that makes sense. Let's hide section 2. Section 1 is our YZ plane. So I'm just going to rename that YZ plane. And that actually is our construction plane, right? To be perfectly clear. And then section 2 is going to be our con rod view. All right. So anyways, rename that whatever you want. So I can just hide or show each of those analyses is plural for analysis. All right. I can show that one or this other one. Great. And now you can see too, we're going to revert position. If I move it by hand, hello, it will shoot back to its 0 position. However, if I'm in motion study and go edit and then stop it at any position, okay, let's go OK, then I have to revert. So that's great. Very good. Very good, everyone. Let's go back. Slider 7 is going to be our piston to cylinder. Excellent. We're at 100,007, everyone. 100,007. Awesome. Very cool. Welcome, everyone. Great to hear from you. Oh, welcome from Nigeria. Very good. Anyone else who hasn't told us where you're from, we'd love to hear from you. We've got ones all over the world, different time zones. This is great. Okay, so what do we do now? We've got the cylinder the con rod, the piston. The contra piston is what we could make up right now. I would say the contra piston is probably the way to go. So let's do that. I'm just going to minimize each of those. Right click, new component. Let's do the contra piston. Okay, right click and isolate. And we can do the same thing over here. Contra piston. This is very simple. I'm just going to, you know what's even easier if I just create a cylinder at this point. Right there. And this is 6.5 nominal. Great. I'm going to go the opposite direction, minus 4.5. Oh, switch screen. Sorry, everyone. Thank you. Boys, oh boys. Get with it there. Get with it there, Learn It channel. Okay, so now we're back. Here I want to go to flat. So I just created a cylinder, everyone. Just created a cylinder. Very simple. You know what? Now that nobody saw that, let's just go undo. So I created the contra piston, isolated it. Let's go create cylinder, XY plane, origin. We put our 6.5 nominal on there, go the opposite direction because that's the direction that it's shown on our drawing. And then I'm going to create a hole right there. This is going to be a flat hole. And we are going to go down 3.5. And our diameter is what? 4.8. That's our contra piston right there. Okay, very good. And have I cast iron? Cast iron is the contra piston as well. So right click, physical material, cast iron, drag and drop. Okay, obviously the grain structure is way too big here too. So iron cast, I think that's the one we want. Yes, perfect. Great. And what we're going to do is we can look at where this contra piston is actually located. The contra piston is located at the very top of our cylinder. So make the cylinder and the con rod visible. And then we go back to our top level component, make that active, assemble, joint. And here I'm going to grab the top of this contra piston and the top of the cylinder. Just like so. Flip it. Motion is going to be rigid. Perfect. Let's go to right click our joint browser. This is our contra piston to cylinder. Very good. And now again, we can go back to that analysis, the con rod view. Okay, turn on our, what is it? Our piston assembly. Go to our motion study. Right click our motion study. Loop. There we go. And this is where compression happens right there. It's perfect. Okay, so let's go OK. Make sure to go save, everyone. Revert to home. Great. Now what should we do? The cylinder head. The cylinder head, definitely. So let's go there. Right click, new component. Almost done, everyone. Cylinder head, right click cylinder head, isolate. Go back to ISO view. Okay, and now what do we want to do here? I would probably say let's create the revolved profile again. So 2-point rectangle, just do the max extremities first. So the complete overall distance here, the height is 14 millimeters. I have 3 millimeters plus 11. And then the outermost diameter is 17. I'm just going to leave that alone. I'm going to turn this into a center line. And then D for dimension, grab those two profiles, and this is supposed to be 17 overall. So again, using center line will create that diameter dimension right there. Perfect. Now we can go in and start adding these other dimensions, just like so. Make sure it's not snapping to everything, to anything else, I should say. Let's put in this. This diameter is what? 4 millimeters. There to there, actually that's not the dimension, so I can delete that. This is what I want. That is 3 millimeters. Perfect. Okay, and we can do the same thing on the inside. Yeah, make sure it's not snapping like over here. Make sure it's not snapping to the midpoint, because then you can't change that dimension. So line, make sure it's not snapping to the midpoint. Anything else? Perfect. D for dimension. This is 8.5 millimeters. And this overall height is 8.7. Very good. So I guess at this point I could also put all of the cooling fins in too. Let's do that separate. And the reason is I'm going to create one. And actually, yeah, I'm going to create one, and then what should I do? Yeah, let's do that. Let's go finish sketch. I'm going to revolve this first of all. Axis right there. Perfect. Oh, we still got our Conrad view on. That's why it looks like that. Okay, and now let's put those cooling vents on. So create sketch. I'm going to pick that YZ plane again. Slice it. P for project. We've got our body right there. I am going to hide body, so we've got the outer profile. And now all I want to do is I want to create two fins. There's a pattern here. All of the lower fins are all the same spacing and dimensions, and then we've got an upper fin as well. So let's do just one lower fin first. I created a 2-point rectangle. There we go. I'm going to create one down there and one up there. Okay, so all fins, it says, are, what does it say here? 0.7. Or no, the gaps are 0.9. This is going to be the gap. 0.9. And then the spacing here is going to be 0.7. Okay, and then we also have a diameter. And what is our diameter? On our screen, it's 10. So I can also create another center line over here. Why not? Center line, D for dimension. 10 millimeters right there. Perfect. Got the sniffles, everyone. Sorry about that. And then up here on the top, someone called the police because you are killing it. JIT CAD Cam, 20 bucks. Everyone, so Phil over at JIT CAD Cam. If nobody's seen Phil, he knows what he's talking about, everyone. He knows, I'm harding you, Phil. I'm harding you. There we go. He knows what he's talking about. He is a master of all things related to cam and much more. I mean, I don't want to downplay his skills, but everyone check him out. He's got a great channel. He's been very generous with me. Phil, thank you so much. Thank you for your generosity. That's very sweet of you. Okay, we've got to team up more, Phil. We've got to team up more. Anyone, if you have any suggestions for some CAD collaboration between Phil and I, we would love it. So anyways, let's keep on going. We're 3 hours into this already. Oh boy. If anyone's stuck with us for 3 hours, that's amazing. Okay, so let's go all the way to the top here. And I am going to, thanks buddy. Awesome. Okay, so we just have to do a little bit of math here. We've got 0.7 times is the asterisk for times, everyone. We've got 1, 2, 3, 4, 5, 6 plus 0.9 times how many gaps? 1, 2, 3, 4, 5. 5 gaps. Okay, 8.7. Beautiful. This is the same gap of 0.9. And this diameter, this doesn't actually have a diameter, so I'm just going to say from that to that is going to be 1 millimeter. And then everything should be, yes, everything is fully constrained. Finish a sketch. And now look at this. We're going to create, and at this point we have to do 2 separate revolves. So I'm going to grab this profile first, the axis. It's bringing up an alarm. It's saying that our body is not shown right now. It's not visible, so we can't cut anything. Now, there we go. As soon as we make the body visible, we can cut. Make the sketch visible again. And this is where, again, renaming our sketches. Main body. And then we've got sketch here is going to be our fins. And now what we can do is revolve this guy to our main axis. Great. And we had to do this in 2 different features because this is where we're going to use pattern, rectangular pattern. Our object is going to be features. Grab that, revolve. The axis is going to be our vertical axis here. And now this is where all the fun happens. We're going to go on up. We're going to go to spacing because we know the spacing. And the spacing is minus the fin distance minus the gap. Okay, and how many fins do we want? 5 total. There we go. Look at that. Awesome. Awesome. I see some other comments. Thank you, everyone. Are projection lines part of the sketch or just showing the outline? I get a bit lost with projections. So projections are basically, you're just wanting to use geometry that's already created, usually 3D geometry, but sometimes 2D as well. And you want to utilize that geometry in another sketch. What can I do to explain this even more? What you could do is if you check out one of my videos, it's on a car part, a car bumper, and I go into projections a little bit more of how they're used, why they're used in a very practical way. I would love to do a tutorial on that in the future too, because working with projections, basically you just want to utilize geometry that's already been created. And sometimes a sketch will not attach itself to geometry or not link to geometry, even though it looks like they're on, connected. They're not. So anyways, I would recommend going to what is it? Do you know what? Maybe I should put that in. I'm going to put a link to that, everyone, right now. Yeah, filter car part, car bumper, title car. Just going to put this into there we go, complex car part. Okay, I'm going to put this in the stream, everyone. There we go. So I'd recommend going over to that. That's a very popular video. Many have appreciated what they've learned, and that's just one aspect of it. It talks about projections a little bit more in detail, and again in a practical way. So let's go back now to our cylinder head. We're almost done, everyone. We're almost done. Let's put in some holes here. I'm going to create a sketch on top, and I'm just going to create a center line from there to there. Perfect. Okay, turn that into construction line type. We're going to put in 2 points. I'm going to make them symmetric to that line that I just created. Put in our dimension. And what is our distance here? 12 millimeters. Excellent. And then we're also going to make them horizontally constrained to the local origin as well. There we go. Oh, something. I see that. So here we go. The center line is not constrained. All we need to do is click the center line coincident to the local origin, and then everything is fully constrained. All right, great. Let's go whole. And actually, before I do that, I need to remember, hold on a second, everyone. So I need to remember what the corresponding holes on the crankcase were. So let me just go back to the crankcase. I can isolate that, find these holes. There they are in the timeline. And this is a 1.6 millimeters. That's important for the clearance size for our cylinder head and the screws that we're going to import too. So cylinder head, I'm going to activate that. We're going to unisolate and then isolate. Hole there and there. We are going to go to clearance this time, and clearance helps us to use a screw. In this case, we're going to go to socket head, and 1.6 is already selected. We're going to go all the way through. When we use clearance, we just pick the fastener type, and it will select the correct size of hole that corresponds to this socket head cap screw, for example. So 1.8 millimeters is the official clearance for that screw. So we're going to go OK. Beautiful. There it is. Next, we're going to do the last one right here. The last hole is on top. And this is a 9BA. So what is the metric equivalent to a 9BA thread? This is of exactly 1.9 millimeters. So I think we can get away with tapped hole. And what does this say? 1.9 millimeters. We don't have the selection for 1.9 millimeters here, so I'm just going to call it a 2 millimeter. There we go, and we're going to go all the way through. Perfect. Let's go OK. Brilliant. Sketches, have they all been renamed? Nope. I'm going to put the holes. There we go. Let's go now to our cylinder. Top level component active. I'm just going to drag and drop that up to the top there temporarily. Assemble joint. Grab this face, the center point, and this is going to correspond to that right there. Perfect. Let's turn on the crankcase. Let's go OK. Find in browser. We've got our, what is this called? Cylinder head. To cylinder. Awesome. Now, you can see we've got our clearance here that runs all the way to our tapped holes down here. So let's see the total length that we need. From there to, and we could actually select, shift select the bottom over here. And this is 25 millimeters. So I think that's probably a little bit too long. Let's pick the top and then maybe pick this point right there, 23. So if I call it 22, 23 millimeters for our screw, that's great. Let's activate the top level component here. I am going to insert a McMaster car component. I'm putting this off to the side so you don't see my login credentials over here. There we go. You could probably have read my keyboard, but that's just my email. All right, let's go to, I'm just logging into McMaster, everyone, because it starts squawking at me if I don't put my my account, if I don't, put in my credentials. So there we go. Beautiful. Okay, let's go to screws and bolts. And what was the socket head? Metric system of measurement. We're going to go to an M2. Let's make this a little bit better, a little bit bigger. And then what did we say? 22 millimeters for the length. That looks probably perfect. Now, I wouldn't use stainless steel because they tend to bind with aluminum, but that's fine. Make sure top level component is active. We're going to download the 3D step file. There we go. It takes a few seconds to download. Okay, I'm just going to grab this, put it off to the side. Excellent. And now we're going to assemble joint. Get the underside of that to the top up here. And look at, so it's not quite long enough. We didn't get a long enough screw. So let's pick the right one, everyone. Okay, so I'm just going to undo. It's gone. Insert, McMaster. Let's go back there. Metric. I could have gone, that's fine. M2. Socket head. And instead of 22, we're going to go to 25. Let's go 25. Partially threaded. Partially threaded is what we want. Click on our tool, on our number there, download. This should be a lot better. And in real life, if we do order the 25 millimeter long one and it's too long, well, we can always, was it even M2? Did I forget this already? No, it's 1.6. What am I doing? What am I doing? I'm getting tired, everyone. I'm getting tired. Thank you for sticking with me. If, you know, this is going to be put on YouTube after for everyone to look at, for schools, for teachers, for everyone to work through. Oh, why use the McMaster versus the Fusion hardware library? Phil, Fusion Phil. That is a great question. Let's do it. The reason is because I like to order right from McMaster. And here's the thing. If I put in a screw from the Fusion, you know, from within Fusion, generally what happens is I won't be able to find that exact screw. And if I use McMaster, I know McMaster is a little bit expensive. Usually I go with Fastenal or something like that. But generally, yes, I like using McMaster just because it's an actual item that I can order and I can see prices of them too. Whereas Fusion, you can't. But Fusion Phil, he's amazing and he knows what he's talking about. So I could always use fasteners with that as well. I like showing so the ease of use on the bill of materials. Yes. We could always go insert fastener, do the same thing. But again, what comes up within Fusion might be next to impossible to find, or, you know. So anyways, you can have fun with that, everyone. I would love for you to experiment with that a little bit more. Insert fastener, go for it. Bolts and screws, it's very easy to use. Have fun with it. I'm just going to go back to McMaster, and that's the other thing within Fusion is that it would find the correct screw size right away for you, so you don't even have to look for it. There we go. Thread size 1.6 and length. We can't even get to that length, which that is too bad. So we'd have to go with 2mm, and that's a good time to change it. So if we go back to this hole, everyone, in our timeline, we've got our hole right there, and we can easily switch us to a 2mm by 0.4. That's our pitch. Okay, there we go. And then back to our cylinder head. If we hover over, click that cylinder, we could, in our timeline right now, it's all the way at the end of our timeline, so we don't need to find it in the timeline. We can just make our cylinder head active, click on that, and there it is in the timeline. So that's the whole point of organizing everything correctly. And now for our size, we can go to an M2. There we go. So is this too big now? No, I think it should work just fine. Back to our top level component, activate that, insert McMaster. Let's go to metric, 2mm, socket head cap screw, a length of 25mm. And we're going to do a partially threaded. Beautiful. Not add to order. And you can see here, package of 10 is $3.35 for stainless steel. Again, don't use stainless steel with aluminum, everyone. It binds up too much, destroys your aluminum eventually. So there's another thing. As we use McMaster, we hopefully look for another material other than stainless, but unfortunately they don't have stainless for this particular type of screw. So we've got to use what we've got to use, right? There we go. Join the underside, this to that, and now we can take a look as we have jointed that screw to our cylinder head. You can see the end result of our screw right here. It's just going a little bit through that relief, which should be fine. But we can always put do our motion study and see if there's any interference right there. So let's go OK. Let's keep our top level component active and just go assemble, and we're going to go duplicate with joints. Grab that screw, click our top, joint it right there. We're good to go. Again, I like renaming these joints. We're just going to go screw to cylinder head 1. I like to copy that entire title so I can just paste it right there to cylinder head 2. Beautiful. So let's just look at our motion study while we're here. Go back to the Conrad view. Okay, and we can make, let's go back to the cylinder head, and we're going to go unisolate so we see the entire assembly. Back to our motion study, edit. bring down the speed, continuous loop, play. So you can see it's not hitting the screws, which is great. Of course, we still have that interference over here, right? But this helps us to see it quite a bit of what's working and anything that's not working. Let's go okay. Revert our position. We're almost there, everyone. 100,000, 8 subscribers. Thank you all so much for your support and your kindness so far. We're so close. We're so close to being done. Now you know how long it takes to do these tutorials. When I produce these on my own, not only do I spend all the time recording like this, but then a ton of time editing after. So anyways, there's no editing right here because it's all live, right? So that makes it a little bit easier. But yeah, these tutorials take a long time to make, a long time to make. So any of your support is greatly appreciated. So we just have a question here. Is Motion Study in the free version? I believe it is. Check it right now. If you can verify that, under Assemble, there is Motion Study. So try and test that. If I'm assuming you're asking because you have the free version. See if Motion Study is there. If it doesn't come up under Assemble, remember S for search, and then just start typing in Motion. And Motion Study, it should come up. Maybe it's somewhere else. But yes, I agree with you, Phil. The editing part is really difficult. Sometimes I spend 20 hours on a half-hour video, editing it. So yeah, this is live might be the way to go, everyone. They're just a whole lot less professional when they're live, but hopefully you find this a little bit professional. So this is looking great, everyone. We are really moving along. What do we have left? We have a stud, we have the compression screw, we have the spinner nut. Okay, so Rambling Geek UK. Yeah, no worries. Just let us know later. You can still access this chat once we're finished the live session. But if you do let us know if you have that in the free version, or if anyone else there that has the free version right now, please let me know. Oh, here we go. Big Planet Life Motion Study is in the personal version. Yeah, you should have it, no problem. Most of the design, the general design features are available. It's some of the, when you start getting into plastic and things like that, that a lot of these, special design features are hidden from you. So anyways, yeah, Motion Study is there. Have fun with it. Beautiful. All right, let's keep on going, everyone. We're almost there. Let's do the compression screw. Right click, new component. Compression screw. Make sure the top level component is active. Okay. I'm just going to minimize these just to see the browser a little bit more. Right click, isolate. And we're going to start designing. So this is pretty cool. We're going to create a sketch on the YZ construction plane. And we are going to create using the pipe tool now. So first, we're going to go 11 millimeters down. And here, this is pretty neat. I don't know if anyone knows this, but if you click with the line, you can see the line tool actually has a line and an arc. So to define an arc, you just have to click and hold once you're done. So this is going to go up and then click and hold, and look at this. It creates an arc. Okay, and then we're going to go off tangent there. Okay, so we've got 11 millimeters defined there. D for dimension. This is going to be 1 millimeter here. Okay, and then our arc. So this actually doesn't define the arc. It does define the angle here. Okay, so 70 degrees, and actually we can flip this the other way, so don't have to do any math in our head, although the math here is very easy. But there we go, 70 degrees right there. And now what we want is 2 millimeters is the pipe. Yeah, that's fine. Okay, So the entire length here from this end point to the end is 15 millimeters. So I'm just going to, and there's another video that I have out there to calculate using parameters what the arc length is, because you can't calculate that easily within the regular measurement. You can, but to actually have it on the screen in front of you, it doesn't show it. You have to always go into the measurement. But to actually define that, there's another video that I have on my channel, which is for highly advanced ones. And I'm just going to find this and put it there. It's the one where I have Pac-Man on the front. There we go. So if you're interested in upping your game and understanding a little bit more about this, please check out that video that I just posted. Okay, so here we go. This is going to be not 15 millimeters total. Let's just put in an arc value here of maybe 2. That's fine. 2 millimeters. Okay. And then we've got this. If we click on it, we can use the measure tool, click on that, and it actually shows us the entire length is 2.433. So I can just click on this, it copies it, and then I can go 15 millimeters minus that value that I just copied, and then this total length, this plus that, is going to equal 15 millimeters total length. So that's fine. This is super easy to calculate, but when you start getting into parameters and forcing an arc length to be a certain value, that's when you need to know advanced techniques. So try that. This is great. Finish sketch. Now let's use the pipe tool, and here we're going to turn off chain selection and pick this bottom one. So we don't want to pick the entire chain. You can see that the compression screw at the end here is actually bigger than at the base. So we're going to just take this one step at a time. Okay, sorry, I'm back. The diameter here is actually a 9BA, so let's find out what that 9BA is. Again, it's around 2, yeah, we did 2 millimeters, right? So turn this into 2 millimeters. Perfect. Right click, repeat pipe. We're going to turn on that sketch once again. And again, just grab that little section of our sketch. Section size here. This is the 2.5 millimeter. Perfect. Join it. And now this is really cool. We are going to create a sketch on this, and this is going to go back to the 2 millimeter. Very good. And now I also want to create a what is it? What is it here? How come I can't find it? Not point along path. What am I looking for here? That's what we want. This is a long path. Okay, so we want a construction plane normal to an edge or sketch line. So this is normal to that edge. So basically what it means is that if we're looking straight down this line, boom, then we've got a plane that's normal to that sketch geometry. So let's go OK. And now when we create a sketch on this, we've got that center point right there. It creates a local origin. So 2.5 millimeters. Perfect. And now what we have for this particular one is we're going to create a, what should we use here? Let's use loft. Okay, profiles. We're going to go from that profile to this profile. And then our rail, we want a center line rail, and it's going to be that right there. Very good. And we actually don't want, I'm going to turn that off, and we don't want chain selection. We just want 1, 2. Okay, so this is actually creating that type of shape. And again, in real life, what you're going to do is you're going to create this as one straight piece and then bend this, heat it up and bend it, right? but this is what we want. This is looking great. Sketch. Sketch 1 is active, perfect. And then we want to put a fillet on here of 1. Okay, and that's kind of looking like our compression screw, right? Create a thread. There we go, 2 by 0.4. And this is going to mate with our cylinder head. And again, what is the size of this? This is not the right size. So activate cylinder head. We're going to isolate that. Okay, grab that hole. And this is actually, oh, it is 2. Perfect. Okay, so that does work. Make the compression screw visible. And believe it or not, this right here, we're going to assemble and joint the bottom of this to our contra piston. So that's how it actually mates, is that those get soldered together, or you know, screwing this in will actually no, they don't get soldered together. Sorry about that. Screwing it in will make the contra piston come closer to the piston and will have an effect on the compression. And of course, as you screw this out, the compression screw will obviously go one way. The contra piston will be locked until your engine actually starts moving, and then it will force the contra piston to go all the way back up to the end of the cylinder head. So that's how that works. It's very interesting. Motion, rigid, that's fine. Great. Right click that joint, find in browser. There we go. We're going to do compression screw to contra piston. Great. Again, if anyone's looking for the plan book for this, just go to the description. There's a link in it. Happy to help everyone. There's a ton of different engines that you can model to build up your abilities with Fusion. So there we go. Okay, so what do we have left? Let's just take a look here. You can always go there, isolate, and then unisolate. And then we can always go to the top level component and go show all components. There we go. Excellent. So that's looking really good. What do we have left, everyone? We have the stud, the prop driver, and the spinner nut, and we're almost done. We're almost done. 3.5 hours. Oh, this has been a while. Okay. All right, let's do the stud first. Again, in real life, we would start with this component, assemble it to the crankshaft before anything. So stud, again, we need to just remember what this value is here on our crankshaft. So there we go, crankshaft, make that active. The hole here is, it's a 2.5 millimeter. Okay, so back to the stud, isolate it. And here we can just create using a cylinder on the XZ. There we go. And this is going to be 21 millimeters. Of course, I have to define the diameter. And this is supposed to be 2.5. Okay. And again, this is chamfered on the edge. We don't have to put that on our model right now. We can do that if we want, but for our engineering drawings or technical drawings, we don't need that. Let's go to thread. Grab that, 2.6, no, we don't want 2.6, 2.5. And just to verify, if we go back to our crankshaft, we can isolate the crankshaft. Again, look at that hole because I've already forgotten what it is. 2.5 by 0.45 pitch. Back to the stud, isolate, 2.5 by 4.5, excellent. Let's go to our crankshaft, make that visible, activate our top level component, bring the stud all the way on over, assemble, joint, and we're just going to grab that endpoint and joint it to that endpoint right there. And of course, you can always look at the analysis as well. Go back to your YZ construction plane and you see that they'll mate approximately at that location. So there we go. Let's go to find in browser our joint here, and we're going to go stud to crank shaft. Perfect. Okay. hide our analysis. This is looking great. Prop driver. If we look at the assembly sheet, sheet 3, you can see that the prop driver kind of nestles over here, lays on the crankshaft. So that's how we're going to mate everything together. Right click, we're going to go to new component. This is going to be our prop driver. Right click, isolate. And what we could actually do, yeah, we can isolate, but I'd like to bring back the crankshaft here. And I'd like to utilize this. So we're going to go for P for project. So here's another instance of projection, everyone. Is P for project. Oh, we have to create a sketch first. So create it on the YZ. P for project. Grab this body. Don't worry about the local origin where that's located. Now I can hide the crankshaft. But this is what we're working with, right? So now if I create a 2-point rectangle, and I'm just going to go from there to there, somewhere like that. Let's go to coincident constraint to the midpoint. And then we have, let's start defining this. Drill 3 millimeters, ream 10 degrees to match. Okay, so I'm going to put a 3 millimeter diameter here. Let's turn this into a center line. Boom. From there to there is going to be 3 millimeters. Excellent. And then I'm going to create a line from here to there. And actually, I'm going to say that I want these two parallel. There we go. Now I also want these two collinear. And what this does is it places the prop driver perfectly how it's supposed to be located. Now let's just finish the dimensions. This is 4. There we go. From there to there is total dimension of 10.8. Okay, and then we're going to create a little relief up here right at the center point. And this is 1.2 radius. So I'm just going to type in a dimension right there, or just a circle, and then D for dimension. Click on our diameter, because on our drawing it says this is a radius value. And I've explained this a million times that if we can, yes, we can calculate this in our head, no problem. But it's easier to go right click with our dimension and go to radius value. And here we're going to make it the exact same as what's on our drawing. So that just is another visual reference that we have input the right value. Okay, so let's go to midpoint now, grab the center of our circle and that line, and it plants it right where it needs to be. Sketch, perfect, finish sketch. Now we can revolve, and we're going to revolve just this right there. Axis, right there. Perfect. Now what we can do with our crankshaft is I am going to assemble as built joint, grab our prop driver, grab the crankshaft, rigid, there. Okay, so now they're rigidly constrained. Perfect. Now this prop driver is aluminum, so we're going to go back over here to physical material. And we've got 6061. We can just drag and drop that. And now A for appearance, and we're going to type in knurl. Classic English, knurl, right? Knurl. All right. Go to faces, drag and drop on the front. Go to our knurl in this design, right click edit, and we're going to bring down the scale just to something that looks a little bit better. There we go. And it's just on that face. That's where the prop, well, the knurled face will grab the prop. Perfect. Save it, everyone. 100,018, everyone. Very excited. Very excited. Again, if we can just talk for a moment about all those who have commented in this chat, this live chat. This is kind of the benefit of doing so, is if you head on over to our Patreon page, link is in the description. There we have it. There's a ton of tutorials, everyone. If you go to collections, there's a ton of courses, there's tutorials, there's ones being released constantly, woodworking, metalworking, RC Engine. The Vega 30 is one of the best courses that we have made. It's the most popular. But membership, gold membership, $25 a month. You get a whole year membership for anyone who's commented. I will pick one at random and contact you. You will get that gold membership. So a little way that I would like to show my thanks for 100,000 subscribers. And please, the way that you can show your thanks is just stick with us. Give us good feedback. If you don't understand something, or even if I've made a mistake, don't worry about it. Give us feedback. Give me feedback, and I am happy to roll with it. So let's keep on going here. Find in browser. This is going to be our prop driver to crank shaft. And now, everyone, we are on to our last but not least component. This is going to be our spinner nut. So right click, new component, spinner nut. There we go. Right click, isolate, create sketch. I'm going to create it on our YZ plane. For everyone who's looking for a 3D connection product, please look to the link in the description below. They're amazing. They help to elevate your CAD, work immensely. So please consider buying one. I have the compact version right now. I've used all three: Pro, Enterprise, and Compact. I love the Pro. I would have stuck with the Pro, but I travel a lot right now, so I went with the Compact, and I'm fine with that. But the Pro is really nice. It works well with Mac as well. So anyways, let's go back to our spinner nut. I am going to create, let's go to, again, we can do our 2-point rectangle and just create the extremities of this. So our dimension here is somewhere more than 10 millimeters, and then this is going to be 12.6. Let's just start off with that, and then we're going to do our, this is actually kind of funny. It's almost, well, it is a spline, to tell you the truth. It's probably just free-handed, but what I'm going to do is, let's go to center diameter circle. I'm just going to create a tangent constraint right there, and then a line from there. Where should this go? Somewhere to there. Let's make it tangent. This is all freestyle as well on a lathe probably, so don't worry about it, anyone trying to make this perfect. I'll just call this 8 millimeters. There we go, something like that. And then here, from that to the end, let's just go 4 millimeters as it shows on the drawing. There we go. And I could always trim this as well. Doesn't really matter. Finish sketch, revolve. There we go. Pick that closed profile, flip it around. Okay, that's looking good. Create. On this face, we're going to do a polygon, and we'll do a circumscribed. Oh, I didn't pick the midpoint. That's fine. Right click, repeat. Okay. We're going to create something like that, and it's 10 millimeters from across to across. So first of all, I want to put a horizontal constraint right there. So that locks that in. And then D for dimension from flat to flat is going to be 10. Okay, I had made this with spline, importing an image of the nut. Yeah, you can do that as well with the spline. That's fine. It's really hard. It's really difficult to machine that on a lathe though, when you're working with spline. So if you have a CNC machine, that's easy. But if you work with arcs and things like that, it's a whole lot easier in real life to get that done. But anyways, so that's 10 millimeters right there. Perfect. And then I can just extrude that profile. Beautiful. And we can go all. Okay, so there's the nut. And then a hole right at the center. Again, this is going to be our, I think it was, I've already forgotten. Was it 2.5? Or 2. Anyways, we can fix that later. And this goes how deep, it doesn't show us, but I'm imagining it's supposed to be around 10 millimeters. And we're going to do a drill point on the end. There we go. Oh, and actually, I see that there's a counter bore here. Okay, so it is tapped, but we're going to do counter bore. And then the counter bore is 6 millimeters diameter by 2 millimeters deep, right? There we go. So you can do that with a tapped hole, no problem. Beautiful. Beautiful. And if you don't like this, if it's a little bit too much of a hex, of course we can always go back to the spinner nut, go back to the sketch that we created, right? And we can make this a little bit, what, 5.75. Okay, and that will clean it up a little bit. Now we've got a little bit of a a little bit of a round right there, which helps with, you don't have to file that section. So there we go. Let's just make sure this was 2.5 again, right, everyone? 2.5 by 0.45. Let's go back to the stud, back to that thread, 2.5 by yeah, that's it. Okay, let's go back to our top level component. Bring this here, spinner nut off to the side, join it. So I'm going to grab the end right there. And again, if you're using modeled threads right now, this is very difficult to pick. But that is very easy using cosmetic threads. So pick that face. There we go. Let's turn on the prop driver. Okay, so obviously that's going to be interfering with each other, so we can just bring this on over. Excellent. Okay. And now our spinner nut is aluminum, red or blue anodized. And I think that I've missed some other anodizing over here too, right? Oh, the cylinder head is the same color. Okay, so let's do that. Spinner nut, right click, physical material. Aluminum 6061, and then we're going to go A for appearance, anodized. Oh, sorry, A for appearance, search, anodized. There we go. And I'm going to go to, let's go red, rough red. Yeah, let's go rough red. So as you could see, I had to download it first. If you see those arrows, that means it's in the cloud. You have to download it. Yeah, it's still taking its time here downloading. Interesting. Oh, maybe that's not accurate. Anyway, so let's go back to our cylinder head and make, oh, and this is still steel, I believe, so I can drag and drop that. And let's go back to our cylinder head, right click, aluminum. So I'm going to go physical material, and we're going to drag and drop the 6061 there too. Great. Joint is still there, still needs to be renamed, browser. So we've got spinner nut to stud. Excellent. So here it is, everyone. Right click, show all components. And we are done. We are done. So here we could also go back to the motion study, right click motion study, edit. You know, bring down the speed, endless loop. Okay, you can see over here, this is the cool thing, right? Is it's you get the exhaust, you get fuel being dumped into it, and this little engine is going to be running. Delayed question, chat was loading. The way you applied knurling, will that 3D print? No, it won't 3D print. So if you're interested in learning how to do an actual knurl, that's in the Vega 30 course. So right now the behind the scenes is for members only. That shows all of it, including the knurling. But the professional, you know, fully edited for YouTube, I think I'm only at lesson 6 right now, and it doesn't show how to do that knurling. But the unfortunately, that would be so cool if this worked for 3D printing. That would be very easy. But to do a knurl is actually very easy to do if you see that course, that lesson. So there we go. Well, this is it, everyone. So we're not done yet. We're not done yet. Save it. Wow, we're at 100,019 now, everyone. Great, great, great to see. Very encouraging. Again, I could have gone and fixed all those sketches, renamed them and everything. I don't think I actually have many, right? No, many that I missed. But anyways, yeah, that's looking great, but we're not done yet. So what I want to do is show you some secrets of rendering. So right now I could go into design, I could change the workspace to render and do rendering with this basic background, but I don't want to do that. I want to show you how I do it for my channel. So let's go to our data panel. I'm going to go to all projects, and I'm going to go to photo booths and render material. So I have made some photo booths, and I've got the photo booth for Learn It thumbnail. So I'm going to right click, copy, And this is interesting. I have lighting in this and everything. It makes it look like a real photo booth. And if you want to see something about this more in detail in the future, please comment. Please let me know. I'd love to work on it. So click on the clan for clan. I am copying it to this folder location. Okay, in the meantime, I'm going to go back to my pinned projects, Clanford, and here we have the photo booth. I'm going to quickly rename this so that this is easy to find. And I'm going to call this the Clanford Clan 0.24cc photo. You're missing a keyway on the shaft and pulley. Yes. How come you're so generous to me, Phil? What's going on here? Oh, wowzers. Well, thank you very much. Everyone, if you didn't hear me before, please go check out Phil. Please go check out Phil. He knows what he's talking about. If you're looking for post processors, if you're looking for machine end work and constant help and support from JIT CAD/CAM, Phil is the guy to go to, and anyways, thank you, Phil. Thank you very much. That's excellent. Rambling Geek, I import stuff from GrabCAD and I have a project full of them so I can reuse. Is there a better way? And I have a project full of them so I can reuse. Is there a better way to import GrabCAM all the way into Fusion is what you're saying? So I would probably say create folders, create projects based on how you actually use those files from GrabCAD. So I use GrabCAD as well sometimes. And so just create a project by saying, defining what each of those GrabCAD files relate to and try and break them down into easier structured, organized file folders. And that just helps you to find them easier. Some people just put all of them into a folder. It's like they're the same people out there that will have their whole desktop completely littered with icons just because maybe organization isn't what they've learned or what they like. And so that's the same thing. Just get into, I would probably say, better organization habits within Fusion. And that's just it helps not only with finding things, but helps with it actually helps with organizing your individual files, your structure of assemblies and things like that as well, a whole lot better. So anyways, let's go here to Photo Booth. Okay, I am going to open that Photo Booth now, and you can see what it looks like. Oh, we also sell Fusion in the US and Canada, says Phil. So yeah, if you're looking to buy Fusion and have some support with it, feel free to reach out to JIT CAD/CAM. And if anyone's interested, hold on a second. You can also get post processors support through us as well. So anyways, you can look at our Patreon page for that if you're interested. So here we go. Here's the photo booth. You can see this is a very simple photo booth. I've created, these are lighting elements right here. These are just like make-believe or artificial lighting, LED lighting. But what I'm going to do is I'm going to import or insert into current design. So again, I've activated top level component. It's going to insert it as another. And actually, before we do this, I want to show you something. I'm going to not do that. I'm going to go back to the Clanford clan. I'm going to save this, and I'm going to show you an even better way, because this model right here is for manufacturing. There's sharp edges. Again, this is for practical purposes in creating drawings, technical drawings, is that you want sharp edges on drawings because you can specify break all edges a certain amount, and that just means chamfer all edges. Having chamfers on every single item is great for renders, but it's not great for technical drawings. So we're going to go like this. We're going to create a derive, and this is fantastic. So new destination. We're going to create a new part, and I'm going to pick, actually no, I'm sorry. Let's create a new hybrid, and I'm going to pick the entire assembly here, Clanford clan. Okay, let's go okay. And derived is amazing. What it's going to do, it's going to pull our entire design into a new file, anything we update in our parent file, which is this is our parent file, anything we update here will automatically be updated in the derive. But the derive, we can take all of these surfaces and edges and we can edit them. And it won't have a bearing on the parent file. So I'm just going to call this the Clanford clan, same thing, 0.24 cc derived. Okay. There we go. And here, show you a couple things just as a little bit easier on the eyes over here. I'm going to go select, selection filters, turn off, select all, and I'm just going to pick joints for now. I'm going to window select everything and then press V and it hides all of the joints. Make sure to go back to select, selection filters and go select all. It goes back to default so you can actually pick edges. If you don't do that, then you'll try and be selecting things and you're like, learn it channel, you have misled me again, you know? So anyways, here we go. We've got all of our parts, and now at this point, what I want to do is take one at a time, and this is preferred a little bit more on the professional side of rendering, everyone. Right-click, isolate our crankcase, and now what I'm going to do is activate it, and now I'm going to go in and I'm going to put in any fillets that I need to first. Okay, so here I am going to put one in there. Actually, I'm not going to worry about the outside so much. I'm going to worry about anything that really has a fillet on it. In this case, I don't have to worry. I'm going to do a chamfer. And let's go to the entire face here. I'm going to go to all these holes. Okay, and then I want everything on this face. No, I don't want everything on that face. I just want these edges. You want to pick all the edges that in real life will be chamfered. And again, they'll just be broken edges in the manufacturing world. But here we go. Pick faces that have all edges on that face that you want chamfered, and pick individual edges of everything else that you want chamfered. So what's happening here? This is not letting me chamfer these for some strange reason. Oh, 0.25 inches, 0.25 millimeters. That's a whole lot better. And that's even too big. So let's go 0.15 millimeters. Okay. There we go. Pick all those. And why is it? What's happening here? I'm getting some sort of calculation error. Yeah, I don't like that. Okay, let's just do this one more time. And maybe what I'm going to do is, so basically this is for the render, everyone. If you're going to render inside and out of everything, obviously you want to chamfer all those edges and make it look as realistic as possible. And some people will, though they're masters at renders, and they will put specks of dust from PNG files and things like that. And they'll make it look really, really good. They'll put oil stains on it as well to make it look realistic, you know. But basically pick all of the edges, in this case the outer edges, 0.1 millimeters. It's still airing out on me for some reason. Interesting. I don't know why that's airing out, everyone, but it is. Cannot maintain first distance for all edges. Try moving branches in a separate. Oh, okay, that's fine. One more time. I am just going to try this here. Let's try 0.1 millimeters. Okay. And then 0.1 millimeters. Just take one face at a time. There we go. Yeah, that's working now. So sometimes this happens, and that's fine. Don't worry about it. Just keep on working with it. Okay, so obviously something is happening here, eh? Yeah. There, that seemed to work. Hey, if at first you don't succeed, try again. Who grew up on that saying? If at first you don't succeed, try again. Give us a thumbs up or something. I don't seem to have that expression too much anymore, eh? Anyways, we'll get into that. 0.1 millimeters. There we go. I picked the cylinder because that picks the top and the bottom edges. Okay, so that's that. That's the crankcase. I'm going to isolate the back plate now and do the same thing. Again, just the surfaces that are being shown. Excuse me. So here I'm picking the wrong edges here. Okay. Again, we don't have to really go too crazy with things, but just make it look more realistic. Okay, fuel tank assembly, this is where we can go isolate and we can go activate. Perfect. And here there's a lot going on. As we're going throughout this, I guess one thing that we should keep in mind is that we actually have to change. Yeah, we have to go back to the original and make our threads. Let's see if this will make everything break. So go to document settings, cosmetic. We're going to change our threads to modeled. We're getting everything to render takes some time, everyone. I'm not gonna mislead you with that, and maybe we don't have all the time to do that right now. But using derived is very effective. When we change something in the parent and we go to the child derived file, you can see that something's broken up here. It says, well, not broken, it needs to be updated. So if we go update, let's see, now all of our threads should turn to modeled, unless it breaks on us here. No, what's happening? What's happening here? It's not making everything have their modeled threads. Oh, that is a shame, because it should be doing that. But anyway, so I think you get the point. I'm sorry that we don't have time. I'm not going to go through this in great detail. But basically, if you want really nice renders, you make the derive file perfect, and you make the threads so that they're visible and that they're modeled, they're not cosmetic, and make it look as realistic as possible. Because now, if we were to go to the photo booth and we go to the original, insert into current design, again, the original at this point, I have changed it so that it has all of the modeled threads on it, which is perfect. So if we go back there, in fact, the derived, I'm just going to get rid of it. Let's save it. That's fine. We're back to the photo booth right now. And this is where you can have fun as well. You could create a stand for it, whatever you want to do to make it look realistic. But as I bring that on up, again, here's a little trick as well. In real life, it's not going to be standing on that surface alone. It will fall over, it will wobble over, right? So go to Move Copy. Move Copy your components, grab the Clanford, go to your front view, and I'm just going to move this on over, and then look at this. If I shift this on over, is this going to be too top heavy? It will probably fall over, right? So in real life, there's no way that this, maybe it would be able to stand up like that. I'm not sure. Let's just make it look like that. That's fine. Show you some secrets with rendering. So now we've got this, you want to make this so that it's perfect. We don't have time to do that. Okay, let's go OK. And now if we go back to Move Copy and go to Clanford Clan, you can see that my pivot is wrong. The pivot's on the angle of the engine, and we've already rotated that. So I'm going to go back to Set Pivot, and I'm just going to pick anything on the table. And now the pivot is all normal to that table. Check mark Set Pivot. And now look, what I can do is move the engine so that it's really easy to operate on the photo booth. So I'm going to put this approximate in the center. I'm going to rotate it just a little bit. Okay, there we go. And now what I'm going to do is go into render, and we'll just run through this kind of the same way that I do it for my tutorial. So back to scene settings. Doesn't matter about your environment. Keep it on 1000. I could put it a little bit lower. Remember, we have lighting sources now coming from these directions. So I'm just going to zoom on in here. You see it's on an angle. That's fine. I mean, you could put it vertical if you want to. It doesn't really matter. It's the whole point of renders is to make it look as realistic as possible, right? So now depth of field. To see the depth of field, just going to move this on over, position it where I want. Turn on in-canvas rendering. Excuse me. And here we go. Depth of field is selected, but we don't know where the center of What does it say here? Center of focus is located. So if I want the center of focus, in real life, you're centering on focus with a camera, right? And it's going to focus on something. And that's where, once we pick that, we've also got blur of 0.05. If I really want it to be dramatic, I could do something like 0.2. That's a little bit more unfocused. And of course, you've got to let this render out a little bit. My computer is really screaming right now in pain because of how much is going on. But sorry about that. I have to drink some water. 4 hours talking is a long time. But you can see putting in that depth of field makes it look a lot more realistic. And if we're using a micro lens or macro lens right here, I'd probably put a little bit more blur on it, 0.3. Let's try 0.3 blur. And again, that's just making it, there's no rhyme or reason exactly to blur, but it has to do with how big the object is. So you're going to have to play around with the blur. Sometimes it's really small, sometimes it's really large, depending on the effect that you're wanting. But you can see here, putting on the blur makes this look realistic. The lighting source is coming from the top right and the top left. Is anyone enjoying this out there, by the way? So please tell me if you're enjoying this render section. But you can see the lighting from those LEDs is casting these shadows, which makes it look even more realistic. Look at the knurl over here as well. I mean, this is looking really cool. The only thing that's not looking realistic about it are all these sharp edges, because in real life, those sharp edges don't exist. There's a lot more blended, filleted, chamfered edges that you would see on manufactured parts out there. But I'm gonna assume that this is what I want. Okay, so let's go. Come on, let's pick something else over here, because the iterations, let's stop in canvas render. Okay, let's go close. So in canvas render gives you a preview of what the render is going to look like. So now what I want to do, named views, I want to save this. This is what I love. So let's go to name view. I'm going to go to ISO render. And you can call this whatever you want. You can call it a million different things. The views are brilliant, everyone. The views retain your focal length. So again, if I wanted a really macro, zooming in here, and if I wanted to go really, like I'm using a macro lens, right? Okay, so I don't really like that perspective. But let's say I save this view right now, it will retain the focal length, which is really handy. But I'm going to go back to the ISO render. It resets the focal length to the way it was. And again, we've got in-canvas render waiting for us. It gives you a preview. We love it. Anything else to change here? Depth of field. Again, we can change the brightness down a little bit. In fact, let me show you this. If I bring that all the way down to 0, and now I go in-canvas render, now it's like you have no lighting sources from the ceiling. It's just using those two fake LED sources in the background. And that's a really cool look as well. But it's totally up to you. So change the brightness to what you're looking for. I'm going to go back to 1000. That lights up everything. Maybe I want a little bit darker. Okay, let's try 500. There we go. Yeah, 500 is good. Okay, stop the in-canvas render, go to render. And here we go. I am going to cloud render. Don't use that because then you have to use tokens. Go to local, advanced setting, go all the way to excellent. And here, one other thing I didn't talk about. Go back to scene settings. And you want, right here, aspect ratio is 16:9. So usually it doesn't show anything here. Go to the 16:9 or go to square, whatever aspect ratio you want. You see these borders over here, the darkened borders? Though that means that this is the scene. So anything within those darkened borders is what's going to be rendered. Okay, so if we go to square, all this will be rendered. Anything in the dark, the shaded portions will not. So pick your profile first. Right? This is what I use for my thumbnails, 16:9. And then when you go to render, the little tea kettle right there, local render, advanced, this is going to be a really nice render. The max render you can go to is 4000. I'm just going to go to 2000. As soon as you do that, go back to the aspect ratio and make sure to select 16:9. Select whatever you've picked in the scene selection so that it's the same. Anyways, I'll go to this because it will still take some time. I'm going to hit render, and this is going to do a local render. Now my computer is really upset with me because now I'm starting to render I'm doing streaming. I've got Windows open galore on my second monitor, so my computer's not going to be happy with me. But 2000 by 1125 is a good enough render. You can go all the way up to 4000 as your max render, local render. But this is going to take about 6 minutes. So anyways, we've hit the end. I mean, this is great. If anyone out there still wants to comment or express anything appreciation for what you've learned, I would love to hear from you. I'm just going to wait for this render to finish. Let's finish off this tutorial by saying something like this. Again, thank you all so much for your support, your amazing words, your encouragement. Again, I'm just a normal guy. I am no different than any one of you. And but I love teaching this, and to have ones that are excited about what they're learning, to see your different projects as well. I mean, if you're interested, you can head on over to our Discord page. All of that is, if you become a Patreon member, you can become a free Patreon member, and it will automatically link you to Discord. The benefit of Discord is we've got an amazing community. You can share screenshots, live recordings. You get help from other people. Obviously, I'm not available all the time, but Discord can help you to connect with others with the same goals, CAD, CAM, and anyways, if you want to join that would be great. If you became a paid member, a subscriber for our Patreon channel, then you get special roles for Discord, which that has its own benefits as well. But yeah, I really appreciate it. I have a couple of questions and comments that I want to just address while this is still rendering out. Would want more cool stuff like this. Okay, thank you for that. This has been really amazing. I'm inspired. I know someday I'll be somewhere. Excellent. Just take it one step at a time. And who else do we have? Been here since 10K subs. Congratulations. Thank you so much for being here since 10K. I know a few of you out there who have been here since just a few subscribers, but 10K was early on, still with very low professional, low quality videos. But definitely that's been an awesome to have your support since then. Let's see, who else? How have you worked in doing CAD? Yes, very much so. I've started working when I was 12 years old. And again, that's all in that podcast that I created. I started working on a CNC machine, a very nice CNC, Morisiki SL253. Look it up. It's an amazing live tooling lathe, 10 station turret live tooling. And so I started programming them at 15 years old. And then I started doing CAD work and doing all of that, which is all in line with manufacturing. So doing that at a very early age. I worked in the oil industry. I worked. We did a mold for Coca-Cola, which was really cool. It wasn't the best experience in the end, but what can I say about that? I worked in an avionics shop. We've done a ton of different work. But I love CAD work. I love teaching. I love all of it. I love CAM as well. Most of my time is programming multi-axis CNC machinery, and so manufacturing out there. If anyone's looking for manufacturing work, I would love to work for you. I did a major job for a car rotor company a couple of years back, which was a huge success using configurations, and they actually showcased my work on a major what would you call it? There was an event, and I was invited to it. Couldn't make it, unfortunately, but it was quite so far to get there. But it was a blast. It was amazing. So anyways, yeah, I've been working at CAD for a long time. Long time. Kind request, can you make a video on a parametric propeller? I will put that on my bucket list for videos, but thank you for your request. Parametric propellers are no easy feat. There's a lot of things that you have to keep in mind. Thanks for your time. You made it over 100,000. Thank you, Aussie Daz 60. Very much appreciated. If you don't mind, what do you do part-time apart from doing this? Out of the topic, though. I do many things part-time. I am a volunteer most of the time, actually. And and it's something that brings me a lot of joy. I do CAD work, I do programming work, design work to pay the bills. But I have a lot of fun hobbies that I like doing, and obviously a volunteer. Many, many nice things in life. So what did you do and what did you study? Sorry to intrude on your life. What did I study? So you mean is when it came to schooling, right? So I, again, since I was working at such a young age, I was kind of focused on CAD/CAM and manufacturing. Manufacturing was the main part of my life. And I took some schooling actually in Franken in Germany at the DMG Mori facility. So that was just a little bit of some education that I received. I've done a bunch of other education, not really too important. But yeah. Advise a boy from Kenya, Africa with only a phone and a dream. Do you have Fusion? Do you have access to Fusion? If you do, there is a ton of different work that you can do. I would suggest, first and foremost, that you go through all of our tutorials online, and you understand the principles of it. After that, I would highly suggest that you look up our Upwork channel, our Upwork page. Right now, I am posting every once in a while very quick jobs, and I have intentions to use these for some tutorials out there. But if you're interested, it's not a huge amount of money, but it's a little bit of money here and there. So find me on Upwork, and if you're interested and you pass the test, then go for it. So start off small. You don't start off big. Just keep humble. Keep working hard. And believe me, a lot of hard work has gone into this channel too. So anyways, thank you. Weston's the best, and I love it. Congrats. Thank you so much. So anyways, everyone, let's see the what is it here? The render is almost done. I am going to put this on our Patreon page. I'm going to create a post where it's going to have access to this live session. This live session can be viewed on YouTube as well. I'm going to put it on there with this file as well, so that you can have fun with it. I won't put the photo booth on there because that's kind of proprietary. So you can make your own photo booth. But anyways, I'll put the engine on there. You can have fun with the engine. Those are for all our paid members as well. He's currently accessing SolidWorks. Excellent. Yeah, SolidWorks is good too. I've got tutorials coming out on SolidWorks, so stay tuned with that. The render is now done. Okay, so that's what it looks like. I am just going to pull this off to the side, and let's hope that, yeah, so now it's not showing you all of my different files over here. So let's just go to engine render. I'm going to save this on my desktop. I just pulled that off to the side because I don't like showing all my folders off to the side there. Okay, and then what we can do is, let's see. I'm going to go back to live subscribers over here. Let's go back to the Finder. I'm just going to pull up that engine render for everyone. Oh, it didn't work entirely. Hang with me, everyone. Just getting to the render. I'll put the render on the Patreon post as well. There we go. Save it. Save it to the desktop. Okay. Sometimes you have to let it save a little bit more. There we go. Clanford. Oh, this looks pretty cool. This looks great. Okay, let me just create a new scene for everyone over here. And I'm gonna go render. Sorry, this is all live, so sorry about that, but this is the nature of what's going on. Mac screen capture. Okie dokie. And then we're gonna go all the way to Clanford. Okay. All right, everyone, here you go. I just have to resize it so it makes sense. And then show you the final render. Thanks for sticking with us here, hanging in. Okay, here's the final render. Let's go to, oh, see, oh, you saw all my movements over here. Oh, that's not fun. That's not professional. Okay, There you go. There's the render. Everyone can see it. Sorry about that. Can I get the Upwork link, or how can I get to you? Yeah, you'll just have to search for me on Upwork. That's all you have to look for. So yeah, you'll find it. You'll find it. It's my profile's all over there. So just go to my bio in the description, and you can find Upwork on there and all sorts of other things. So there's the final render, everyone. Doesn't look too bad, eh? Doesn't look too bad. So again, 100,033 subscribers. Thank you all so much for your support again. Thanks for hanging in. I'm going to pick the winner, let you know as soon as possible. Until then, thank you all for learning with the Learn It channel. Can't wait to see you at the next one.